Sir, is the screen visible?
Yes, sir. It's okay, sir. Yeah.
Okay, sir. Good afternoon, everyone. I'm Dr. Jayan. Sir, can you mute yourself? Good afternoon, everyone. I'm Dr. Jayan, working as Assistant Professor in Center of Excellence in Product Design and Smart Manufacturing, Maulana Azad National Institute of Technology. So my topic is like additive manufacturing of multifunctional composites. Like these are the table of contents. So multifunctional composites, we can tell like multi materials. Yes, sir.
Yeah, there is some disturbance in your voice, sir.
Sir, you have to mute yourself, sir. Otherwise, yes, sir.
We have muted everybody, but there is an echo in your voice, sir.
1 second, sir. Sir, now it is okay.
Still, we are facing the same problem, sir. Still, we are facing
Sir,
the same
now
problem. It's okay now, sir. No problem. It is
Hello,
okay
sir.
now, sir. You can proceed. It's okay, sir.
Hello.
Jain, sir, it's okay. Jain, sir, can you hear me? Hello?
Sir, sir, now it is okay.
Okay, sir.
Okay, sir.
Yeah.
Incredible. 75% off on electronics and accessories, no cost EMI. Amazon Great Indian Festival starts 23rd September.
Sir, can you see the PPT?
Sir, I can see the PPT, sir. Introduction to
Okay, sir.
multifunction.
So normally we'll make a composite, so it is having only the structural strength. But if you take a multifunctional composite, so it can be like used for 2 or more functions simultaneously. So for example, you can take like same material can act as a sensor also. Sometimes it can act as an actuator also. So nowadays, like we are using like battery storage. So for that also we can use this multifunctional composites. Even in biomedical application, or even like nowadays, like if our tire or like car tire or bike tire get punctured, so that can be self-healed, so automatically it will close the puncture. So that kind of application we can use. So for example, you take a composite that is both a lightweight and can store electrical energy also. So for example, nowadays, like drones and all, they are making with this multifunctional materials. So it can serves as like strength wise also it is better, and it is having lightweight also, and also it can store electrical energy. So why we are using additive manufacturing? Because first thing is like a design freedom. So we can make any complex shapes or whatever shape you can make in the CAD model that can be directly 3D printed. And even in the internal structures, not possible with traditional methods. So even thin walled structures or whatever complex like structures we can be able to make using this additive manufacturing. And even we can change the properties of the material. So for precise placement and orientation of reinforcing fibers and functional fillers, even nowadays metal 3D printing, we can make alloys according to our wish, like a super alloys, those kind of alloys we can make, and what percentage material you want, that you can just enter in the computer, and the 3D printer can make with that composition. So one more thing is the material efficiency, because like a wastage is very less when compared to the conventional manufacturing process, and we can make any customized thing. So for example, you take implant and all, we can make implant according to the patient specific data. Also, we can integrate multiple functions in the single part. So that's what I told. If it is a conductive material, no need of wiring also. Even in drone, like no need of wiring, directly we can connecting using that like a structural material itself, we can directly connect the wires. So these are some technologies we are currently using for this multifunctional material. First one is like fused filament fabrication. Most of you would have like seen this technology, so we'll call it as FDM also. So it is like extrusion based 3D printing, and we are using thermoplastic filament. So same material we can mix with some carbon fiber, or we can use a graphene, or you can mix with carbon black also. Those kind of conductive material, so it will increase the strength also. Meanwhile, it will make the bad conductor into good conductor also. So sometimes we can use like a semiconductor also. So those can be used in electronic application. So like if you see the advantage, it is low cost and widely accessible. So anyone can buy and anyone can use. And one more thing is like environmental friendly also. But the disadvantage is like anisotropy. In each direction, the strength will be different, and whichever direction you are printing, that direction it will be like good. If you are taking in the 90-degree perpendicular direction, the strength will be less. So that is the problem with the FDM. So similarly, we are having direct ink writing also. These kind of things we can make use of. Direct ink means like we can use a conductive ink, and we can print on the like polymer. So you can make some circuit board kind of thing. So extrudes a viscous shear thinning ink, so highly flexible with wide range of materials. So it can be made with polymer, ceramics, and metal. So it is like multi-material 3D printer. But the disadvantage is like a slower printing speed, and requires specific rheological properties. Before we are doing printing, so we have to test the rheology and all. So based on that only we can print. And one more method is like SLA. This also you would have heard about, like that is based on the photopolymer. We can make the it uses a UV laser to cure the photopolymer resin. When the light falls on that, the polymer will become solid. So here also like we can see some advantages are there, high resolution and surface finish. So mostly these kind of technologies we are using for making mold for jewelry and even like dental application we are using SLE. So nowadays like the latest thing is like hybrid additive manufacturing methods. In the same 3D printer we can print different materials also, metals, polymers and ceramics. So these are the need for the multifunctional composites. So traditional composites focus mainly on the structural strength, but increasing demand for the material that serves multiple roles. For example, like if you need a strength and conductivity, similarly we can combine like a strength and like auto healing properties. Those kind of things we can be able to make using this multifunctional composites. So these are the advantages: reduces weight and material usage in engineering system. So instead of using different materials, so for example, I have to use metal for the strength. So similarly, polymer for the lightweight. Like different materials we have to use. Instead of that single material, we can use for multiple applications. So it also enhances efficiency and sustainability. So even you can, if you are using polymer or metal, so that can be recycled also. Like we can melt it and we can again make into filament or make into that resin. Again, we can reuse also. So these are the different types of composites we are making in additive manufacturing. So one is like fibers. So fibers are like carbon fibers, fiberglass, Kevlar. So for example, carbon fiber, if you take like that CFRP, it is used in automobile and aerospace application to reduce the weight. Meanwhile, we can increase the strength to weight ratio. And like nowadays, most of the sports car, they are using CFRP, carbon fiber reinforced plastic. Even in aircraft wings and all, they are using some part of this carbon fiber reinforced plastic. Even like unmanned aerial vehicles, that is directly like drones, those kind of things, we can make use of this lightweight material. It will give strength also, and the weight also can be reduced. So Kevlar also you would have heard about. So bulletproof jackets, we are making use of those kind of fibers. So even like nowadays we are able to make the lattice structure and even with structures with the negative Poisson ratio. So those kind of things we can use for bulletproof applications. And functionality, if you take like it will be having the higher stiffness and strength to weight ratio and useful for structural applications. Chopped and the discontinuous fibers also we are using. Short fibers are dispersed within the polymer matrix. So here functionality is we can improve the strength, stiffness, and even thermal conductivity also we can change based on the amount of the short fibers. And even you can make nano composites. The advantage of nano composites, that's what I told, I can make a conductive material. So I can use a carbon nanotube, carbon black, or graphene. Those kind of materials I can make conductive, make the polymer into conductive polymer. So functionality is like enhances electrical conductivity, thermal properties, and also it has the structural sensing capabilities. So even this kind of composites we are using for structural health monitoring also for like human health monitoring system. So nowadays we are using smartwatch, so using this kind of material we can make smartwatch kind of devices. So latest technologies like with the help of sweat we can be able to like predict our health. So final thing is the 4D printing. So this uses the smarter material that can change shape or function in response to an external stimulus. Um, like for example, piezoelectric crystal and all, it can change the shape and structure based on the stimulus we are giving. So either we are giving the mechanical energy or will give the electrical energy that will be converted into mechanical or electrical energy. So those things will change the structure. So similarly, I am telling like a self-healing properties. So like it can be like if some puncture happens or some problem happen, even our human body, the blood clotting is an example for 4D printing. So automatically blood will clot if we are having some injury. So those kind of nature inspired engineering we can do. So this can be used for like self-assembly, self-healing and adaptive structures. Even nowadays they are using for plastic surgery and all, we can use 3D printing. So nowadays like we are using different materials in this functional composites. So we are using the additive manufacturing. Also we are using like AI and ML design and characterization. So based on this, we can design, make the design also automatic. Like we are doing manually, that can also be like optimized using this AI and ML like algorithms. And here we are using like different materials. So for example, you take metal and alloy. So I can make like inner part of iron, outer part I can make use of like a stainless steel. So instead of making the whole stainless steel, I can make like a core in inner part will be like a normal cast iron kind of thing, low cost material. Outer thing will be like stainless steel. So I can increase both the strength as well as like properties also, but I can reduce the cost by using like a less amount of stainless steel, more amount of cast iron. So similarly, I can use like a polymer based composites. That's what I told, like even in 3D printing, like FDM, we are using thermoplastic polymers. So that can be mixed with the graphene, like carbon black or carbon fiber reinforced plastics. So that can be used for multiple applications. So similarly, sustainable composites means like it can be like either recycled or it can be like biodegradable composites we can make. So those kind of things we can use for medical application and sensor materials also. Like if you are making some conductive material or inductance based sensors, so those kind of sensors can be used for multiple application. For example, like we can measure the level of the liquid. So that is like a level sensor we can use. So similarly, we can predict some kind of gas or chemicals. So like without human intervention, we can detect the leakage of gas and we can detect the leakage of some chemicals in the industry. So for those also we can use these sensors. So these are the different process we are using and whatever composite structures we are using. So first thing is like polymer matrix. Polymer matrix means will be like if you take SLA, we can use like a liquid resin. But if you are taking triple F or FDM or this direct in like wire method, direct ink writing method. So we are using like liquid resin and solid filament also we are using, and SLS we are using powders. So some cases we are using like a gel. Reinforcement can be like either short fiber, continuous fiber, or nano materials. Based on the required property, we can mix with the short fiber, continuous fiber, or nano materials. So composite microstructures, if you take like it can be mixed with the liquid resin and this any one of these fibers. Similarly, we can mix with powder and shorter the nanofibers, and gel also can be mixed with the shorter the nanofibers, and solid filament can also be mixed with the shorter the. But like based on this, this can be divided into three categories. One is like a random arrangement, and next thing is like anisotropic alignment, and final thing is the digital oscillation. So thing is that random arrangement means whatever way you want, that can be randomly arranged. Anisotropic means like in one direction it will be same, other direction it will be having different properties. So digital oscillation means like we can digitally change the orientation, and we can make the customized setup to have the like uniform distribution of the fibers. So this will increase the composite property. So mechanical stiffness and strength will increase. Also, we can include the electrical and thermal conduction properties. So sometimes we can use the same material for electromagnetic absorption, that we'll call it as EMI shielding, and magnetic polarization also we can use. Sometimes this kind of material can be used for biocompatibility and biodegradation. So like for that design methodology we are using is topology optimization to make the structure so with less amount of material, and AI or data driven approach, so for optimized distribution of the filament as well as the structure, and finally we are making the CAD model, and even sometimes we are using bio inspired approach. So that is like for example you take our entire body. So thing is that like upper layer is made up of skin. So after that we'll have some like a muscle is there. So inside that like we'll have the different cells are there. After that bone is there. So like that we are having different layers of material so that it will have the better strength. So same kind of thing we can take as an inspiration and we can make the material. That's what I told, like I can make using different materials in the same technology. So based, if you are doing all this thing, so like even we can do this mechanical damping and energy absorption. So that is like we can use for like automobile application. So it will increase the impact resistance and tunable thermal expansion and mechanical Poisson's ratio. That's what I told. The example is the bulletproof jacket. So we can change the Poisson's ratio of the material also. Based on the structure, the Poisson ratio will change. Also, we can use for electromagnetic shielding properties. So for example, you take a laptop and the mobile phone. So both are operating at the same frequency. So if you are using mic also, so sometimes you will be having some disturbance. So that disturbance will call it as electromagnetic interference. So that can be prevented by this kind of materials. So also we can use for acoustic absorption and damping and clacking. So this can be used for windows or even walls. We can use for this acoustic absorption. And final thing is the 4D response or actuation, that is like self-healing properties. So these are some research article we have already studied. So thing is that like here in the first figure, you can see like whatever short carbon fiber, if you are using like a conventional method, you won't be able to control the direction of the short carbon fiber and all, because like it is a chopped fiber. So it will be like randomly distributed. But in case of 3D printing, so we can make the carbon fiber reinforced composite with the controlled fiber orientation. You can see like in the printing direction only, it is distributed. It is not distributed in the other direction. So even after the SEM image also shows like fractography shows that like it is uniformly distributed also, and it is in the same direction, unidirection filament. So this will increase the strength 2 times or 4 times more than the actual composite made by the conventional method. And this also like this can be made in FDM or FFF process. And similarly, we can use SLA to make this kind of structures. So this will be like clear structure. So these kind of things we can use for like tooth aligners, those kind of things. So for others, they won't see like you are wearing the tooth aligner. In olden days, we are using clip kind of thing. So for aligning the tooths. So nowadays they are using this kind of material to make the alignment. So even in aerospace also, we are using this 3D printed continuous fiber carbon fiber composites for drone parts and aircraft interior components. So this will reduce the overall weight and improve the fuel efficiency, and also can develop conductive structures. So thing is that in addition to the strength and the lightweight structure, so we can have the conductive structures also. So no need of wiring and all. We can connect in any part. And we have like even the structural health monitoring, like if there is a crack or something is there, that we can find, because it's a conductive material, there will be change in the voltage or capacitance will be there. Based on that, we can see like some crack or damage is there in the structure. So similarly, that's what I told, the structural health monitoring composites with embedded sensors that detect stress and damage in real time. So that is in the structure itself, we have the sensor capability. So it will also show any damage or any stress is there. So similarly, we can use for automotive applications also. So main thing is like energy observing structures. So lattice structures printed with carbon fiber composites for improved crash worthiness. So that's what nowadays they are doing, like crash test and all. So these kind of structures will increase the impact resistance. And we can integrate the sensors and the energy storage in vehicle parts. So this can be used for battery, those kind of things. And even custom tooling and jigs can be made using this rapid manufacture lightweight tools for assembly lines. So next application is like biomedical application. So we can make a custom implants, so personalized bone scaffolds and prosthetic limbs with tailored mechanical properties and even biosensing. So for example, nowadays they are making 3D printed stents and all. So similarly, like this shape memory alloys are we are using. So those kind of materials will have the both the structural properties as well as it is having some actuating properties. And biosensors, we are using 3D printed conductive nanocomposites for wearable sensor to monitor the vital signs. So that is like we can measure our heart rate and oxygen level, all those things we are using this biosensors. So that's what I told, the smart wearable device. What we are wearing is like smart watches. but everything is separate. Like whatever we are in is like a proximity sensor will be there, and we are having heart rate sensor. Everything is separate. But in case of biosensor, we can integrate all those capabilities in a single material. So similarly, we can use for soft robotics. Nowadays, surgery and all they are doing using soft robotics, and whichever place human cannot enter, the soft robots will enter. Even this bypass surgery and all not required. Directly, we can use the soft robots for doing the brain surgery and heart surgery and all. So actuating structures will be there, composites that can change shape in response to thermal or electrical signals. So mimicking the biological movement. So same like a caterpillar, we can make a robot. So that will make a same movement like the caterpillar. So embedded electronics, so integrated circuits and sensor printed directly into the body of the robot. That is also possible because of this 3D printing. We can print multiple materials in a single printer. And in electronics, we are making flexible circuit and thermal management materials. And in defense, we are using smart armor and multifunctional drones. So smart armor, that's what I told, bulletproof jackets. We can make the bulletproof jacket with the 3D printer. So that will be having like a various capability, and even with a negative poison ratio, the bullet cannot enter the jacket. And even multifunctional drones also they are making, so that we can even prevent from the radar also. Like if you are making with the conductive material, that is like a polymer based conductive material, like enemy's radar cannot detect our drones. These are some application we are using in the medical thing. So like normally bone will be like this. So same structure we are mimicking using like a 3D printing. So different structure. So actually we need this porous layer and dense layer. So it will be different in each layer. So this is because like our cell has to grow in this gap. So if it is fully solid, cell cannot grow through this. So normally our bone will be like porous. Through this cell, all the tissues will grow. So this can be used for tissue engineering application. Also, we can make a complex structure like this origami structures. So that is like we can make like a folded structures that can be improving the mechanical properties, and it is having different mechanical properties at different temperatures. So this kind of structures also can be made using. So this technology they are using is direct energy deposition. So this is a laser based technology. They are using atomized powder to make the structures. So similarly, we can make the recyclability of the biocomposite also. So whatever composite we are using, again we can like dissolve in the chemical, and we can make the recycled composite also. Once the life is over, again we can recycle to make some other material. So even you can see like, but the strength will reduce, but still we can use for different applications, and we can mix with some fiber also, and that fiber also it is like a biodegradable fiber, and that will improve the strength also. Similarly, we are making like if you take a PLA material that is made from the cornstarch only, so we can make like biocompatible and biodegradable materials also. So these are some example for like energy storage devices. So already you would have heard about like whatever so here for example you take a bridge. So in this vehicle will move, and we are having the like a triboelectric sensor composites, and so this can be used for like generating the energy based on the vehicle movement. So if the vehicle is moving over the road, so due to friction and whatever load we are applying, so that will be stored in the battery. So those kind of generators we can use. So same kind of technology we can use for monitoring the brain signals of the mouse. So same thing we can in future, maybe like we can control our brain using this 3D printed technologies. So it is having multiple layers. So it is having like a gold layer, Teflon layer, and it is having a magnetic field oscillation. So one more thing is like this structure is having like we doesn't require a battery. So automatically like by motion of this rat, and we can generate the power also. So this is like a self-powered magneto-mechano triboelectric nano generators. This can be used for measuring the health condition of the rat, and it is directly connected to the brain of the rat. So that is like we are placing on the skull, so we can record the brain signals. So same thing we can use for like prosthetics also. Nowadays you can see like prosthetic arms and all they are using functional, fully functional prosthetic arm that also can be made using this kind of technologies. One more thing I told like this EMI shielding. So you can use the conductive composite. So for example, they are using carbon fiber reinforced PLA. So this can be used to reduce the interference. So that's why we call it as shielding, electromagnetic shielding. Similarly, like here you can see like a heat sink is there. Normally heat sink will be there. So this aluminum strip will be there. This can be like coated with this aerogel kind of thing. So this SiO2 aerogel particles, so that is mixed with this MnO2 and silicon oxide collides. So finally it is forming a multifunctional material. So here you can see in the simulation, normally without this heat sink, so how it is looking like this is the temperature gradient, like this it is showing like it is having better cooling properties. So we can like even in our mobile phone or computer, so we can cool the components with this 3D printed structure. So here you can see this is the 3D printed structure, and this can like encapsulate this heat sink. So normally it is made up of aluminum, so that can be closed with this polymer based thing. So finally we can reduce the temperature of the components in the computer and the mobile phone. So similarly, we are using structures for like missiles and all. So this is actually a Microsoft launch vehicle. So here, like normally the metal lattice pin, if you are making, so it will cost around $50 to $80 per machine hour. So this is reduced to half because of composite lattice pin with antrim fiber reverse zones. So it will reduce the weight also, and it can reduce the overall cost also by reducing the man hour for manufacturing this kind of structures. So similarly, we are using structures for making satellites also. Composite solar battery panel, 45% weight reduction in comparison to aluminum prototype. So normally aluminum we are using. So instead of that, we can use polymer based composite. So these are the futures of the manufacturing. So we can do topology optimization of anisotropic structures, and even free-form printing means whatever structure you want, you can be able to make. That we'll call it as free-form 3D printing. So normally 3D printer, if you take, it is only 3 axis will be there, but it is like we can integrate with the robotic arm, so it can be having like more than 3 degrees, like 3 degrees of freedom. So it can be like 6 axis, even up to 11 axis we can do 3D printing. And composite and multifunctional adaptive self-healing material, that's what I told an example of tire puncture. So automatically it will heal. And similarly, even in our house, like pipeline leakage is there. So if you use the self-healing material, so automatically it will close the leakage. So same thing, we are making those things based on our human body only, because blood clot is an example for this self-healing properties. So I have taken some recent developments in this 3D printing. So nowadays, like normally metal means we have to melt it to like more than 700 degrees Celsius. But in case of this metallic gel, so here we are making highly electrically conductive and can be used to print three-dimensional solid objects. So they are making the metallic conductive, electrically conductive materials that even at the room temperature. Room temperature means we are printing at 25 to 40 degrees Celsius. So solution of micron scale copper particles suspended in water. So they are mixing like copper particles in water and add a small amount of indium gallium alloy. So this will make resulting mixture is metallic gel network within the aqueous solution. So once you do the 3D printing using this, we can get a metal up to 97.5% metal. So and we can make a conductive material. So thing is that we can make the metallic thing at room temperature. This is the advantage of this process. So similarly, like that's what I told, idea from nature. So we are taking the inspiration from the trees and the bones. So we can improve the strength and the different materials interact with each other. If you take bone itself, it is made up of different materials. Like 3D print two types of steel in some circular layer. So using two welding machines. So thing is that using wire arc additive manufacturing, we can make like same circular layer with the two materials. So the resulting bimetallic material proved 33 to 42% stronger than either metal alone. So thing is that if I'm mixing with either mild steel or stainless steel, so but final property will be better than both the materials. So used to make a high performance medical implants or even parts for space travel. So that can be made, an application where they can combine a very hard material and soft material almost simultaneously. Thing is that I can mix aluminum with titanium also. So I can have the both the properties. So also it can increase the corrosion resistance. So for example, stainless steel core was created inside a outer casing of cheaper mild steel, like that used in the bridges and the railroads. So normally, like if you take the railroads and the bridges, so inner thing will be the mild steel, only the outer coating will be the stainless steel. Those kind of structures we can be able to make using 3D printing. So similarly, even you can make that's what I told, the piezoelectric material, quartz glass structures will be able to make directly on the semiconductor chips. So a hybrid organic inorganic polymer resin is used as a feedstock material, and here we are using this polyhedral oligomeric silicon molecules, which are small cage-like silicon dioxide molecules equipped with organic functional groups. So these things normally we are printing in 650 degrees Celsius. So 3D printing to form a 3D nanostructure. So for that we have to heat up to 650 degrees Celsius. At the same point, the inorganic cages and form a continuous quartz glass microstructure and nanostructure. The temperature required for this purpose is only half the temperature needed for process based on the sintering of the nanoparticle. Thing is that if you are making these kind of structures, so instead of having like 1300 degrees Celsius, we can make the structures in 650 degrees Celsius. So it will reduce our energy also, and easier to manufacture the quartz glass. And one more thing is we can make optical grade glass structures with the resolution needed for visible light. So that is for photonics directly on semiconductor chips. So these kind of quartz are used for multiple application. Even we can make a nanostructure up to 97 nanometer using this method. So similarly, that's what I told in plastic surgery. This is a method painting a wound, healing into a cuts with a 3D printing pen. We can use a 3D printing pen to heal our wounds very quickly. So the body is pretty good at healing itself. So though more severe wounds can require bandages or stitches, so this can be prevented by a wound healing ink that can actively encourage the body to heal by exposing the cut to immune system vesicle. So this will call it as 4D printing. So it will be having the functionality also, and it will cure your wound very quickly. So this already they have tested with the mice. So it repaired the wound just in 12 days. So mostly if you are taking wound means it will take up to 1 month or 2 months. So that can be cured in 12 days. Similarly, this body health monitoring, we can do using the sweat. So normally we have to take blood for monitoring the glucose level or BP, all those things. We have to check. Instead of that, we can directly use the sweat to analyze the health of the human being. So providing clues to dehydration, fatigue or blood sugar levels, and even serious conditions such as cystic fibrosis, diabetes and heart failure, all those things we can detect using the sweat. So researchers have taken a giant leap towards in the sweat analysis with an innovative 3D printed wearable sweat sensor. So that we'll call it a sweatener. So unique feature of the sweatener is its multi-draw sweat collection method. So which allows for the collection of multiple separate sweat samples for analysis either directly or on the device or sent to lab. So if it is normal, then device will directly give the signals. So if any serious condition is there, we can use that sweat for testing in the lab. Instead of taking blood, with our sweat itself, we'll be able to check the body health condition. So this is the summary of all the 3D printers we have used. So random arrangement for shorter than nano composites, we are mostly using SLA, material jetting or polyjet 3D printer, and SLS we are using binder jet. So mostly these kind of things we are using in soft robots, smart actuators, And even in sports, we are using space exploration and lightweight components. All those things we can use this application. So here the advantages like ease of fabrication, higher adaptability to different types of additive manufacturing process, and we can make isotropy also. We can make all the directions same properties. Uh, Disadvantages like limited fiber loading ratio and hard to avoid fiber agglomeration. So one more thing is like continuous fiber, we can use either of this method. So fused filament fabrication, laminated object manufacturing, inkjet, or automated fiber placement and additive manufacturing. So these kind of structures are used in aerospace components, lightweight automobile parts, and sports equipment, and marine structures, electromagnetic shielding. All those things we are using this continuous fiber alignment. So this is having high specific mechanical stiffness and strength, freedom and control of the inner fiber orientation, engineerable fiber volume fraction and distribution. But disadvantage is like if you take FDM and all, so it is having less resolution and high porosity will be there. Poor interlayer bonding will be there, weak adhesion of the fiber or the resin. So limited freedom of fiber arrangement in 3D. So similarly, like we can control the direction also using this method. So like direct ink writing and polyjet and multijet filament fabrication. So this functional actuators we can make, surgical training model also we can make. So smart electronics and soft robotics we can make using this methods. So nowadays, like latest technologies, we can make the organs also. Latest thing is like they have developed a artificial kidney also. So mostly it will come into the market. So instead of like organ transplant, we can do the artificial kidney. So similarly, like they are planning to print heart and all, so that in future they can make a heart also in 3D printing. So that we'll call it as bioprinting. So tailored material properties, digitally customized microstructure, and multi-material and multifunctional integration can be possible using these methods. And here the productivity will be less because it is customized thing, and stringent requirement of feedstock because we are using medical application. So it like whatever requirement is there that should match. So it should be biocompatible and it should not reduce the health complications will be reduced. So complex process planning and nozzle design also it is required for different materials. So these are the challenges and future outlook. Material anisotropy, like because strength and the properties can vary depend on the build direction. So this is the one of the disadvantage. And one more thing is like interlayer adhesion. So if you take between the layers, the strength will be less. That is due to the weak bonds. And also the cost also it is higher when compared to the conventional manufacturing process. And complex processing parameters. So it is having multiple parameters like temperature, nozzle diameter, or like a layer thickness. All those things like it is in dependent parameters. So we have to carefully look at those parameters and we have to optimize those parameters. Limited material compatibility. So even though like we are having multiple 3D printers, so each 3D printer is for particular process only. Nowadays only they are developing same 3D printer we can use for multi materials, but the cost will be like more than 1 crore. So scalability and cost issues also there. That is like in future we have to integrate the AI also and machine learning for optimized design in the process control and development of new multifunctional inks and the filaments. And we can transition from prototyping to full scale manufacturing. That is like we have to make the mass production, otherwise the cost will be more. So also we can integrate with the industry 4.0 and smart manufacturing. So the conclusion is that additive manufacturing is a paradigm shift technology for creating multifunctional composites. So it offers unprecedented control over the material properties and geometric complexity. So with the ongoing research, these materials will play a crucial role in enabling the next generation of the smart, adaptable, and high performance devices. So this is rapidly evolving field with huge potential for future innovation. So one more thing, like I will show you what research we are doing also. Thing is that we are using fused filament fabrication or the FDM for making the multifunctional composites. So we have selected so actually like this filament is available in the market itself. So we are using the ABS based. So this is actually a thermoplastic that is mixed with the carbon fiber, carbon black. So this will make the material conductive. So this conductive material, we have done the thermal characterization, and even we have done the electrical characterization also. This shows that like this can be used for like making the sensors. So even we check the mechanical properties here, you can see like normal ABS is having better strength, but comparatively like not much difference is there. So even if I include that carbon fiber, the strength is reducing to 22.41 megapascal. So this is due to the like it is making the ultimate strength is reducing, but still that elongation is more when compared to the pure ABS. And so we have made the setup. So same material we have 3D printed, and we made like a parallel plate capacitor. So this can act as a capacitive sensor. So thing is that like we are using for void fraction measurement. So we have filled water and the like normally air will be there. So we whatever level we are filling, that we are noting down, and based on that we are noting down the capacitance value also. So this conductive material will act as a capacitive sensor, and by using this we can measure the level of the liquid. These are the 3D printed sensors, capacitors. So this is the formula for void fraction calculation, and we have compared with the copper also. You can see the same kind of trend we are getting for the polymer also, polymer based conductive composite. So we checked the effect of the sensor thickness and sensor width. If you increase the area, automatically it will increase the capacitance value. So finally, we have found out this thing like this is the sensor characteristics. So, but this kind of thing like we cannot directly use for turbulent flow and all. So for normal thing, linear flow we can use this sensor, but for turbulent flow this is not suitable because the you can see like this is the 6.9 seconds it is taking to change the sudden variation. So the sensitivity is less when compared to metallic sensors. So if you are measuring with copper, you are getting value between like 5.3 picofarad to 20.66 picofarad. But if you are measuring with the same size of like conductive material, conductive polymer material, so it is coming around 3.66 to 6.37. But if you compare these two things, the value is more in copper. But when you see the graph or see the comparison of the thing, so it is also like the value also changing. So instead of metallic sensor, we can use the conductive sensor. So it will reduce the cost also, and you can make a customized sensor according to your requirement, because like different pipes will be having different diameters. So for that we have to buy sensor again and again. So instead of that, we can use the 3D printed sensor, and we have checked the cost also. So if you are making a smaller thing, so it will cost around 1 rupees 50 paise for this sensor. So you can make a low cost sensor to measure the void fraction. So that is like both the water and the air two-phase flow. So same thing we can use for like petroleum industry also. We can measure the like pressure, or we can measure the flow rate. All those things we can measure using this kind of sensor. So one more application already I told, like EMI shielding. Like this black color material you are seeing like a same 3D printed material. I'm using the same material for one more application. So previously I have told like it is void fraction measurement. So similarly I can make use for like electromagnetic interference shielding also. So these are the formulas. So normally we'll measure like if you are using a conductive material, so there will be like whatever radiation we are sending, so that will be like reflected back. But here we are using polymer, so you can see the reflection. It is almost zero only. So actually we have magnified it. So it is between 0 to 0.001. So thing is that it is almost zero. That means like there is no reflection is there, because it is like a polymer. So it will act as a observer. It will observe the signals. Whatever signal we are sending, that will be observed. So this is like absorption. You can see like how much like it is almost 100 dB. So it can observe the radiation, whatever waves we are sending. So that can be observed by this thing. So it will remove the interference between two devices. For example, mobile phone and the laptop, or between like medical devices. So if you are going to an operation theater or ICU, you cannot use your mobile phone because that signal will affect the health monitoring system. So there also we can use these kind of structures. So this also we have checked like a different thickness and how it is affecting. So it is almost like 62.54 to 106.63 dB. So that we can shield using different thicknesses. So better values are obtained for 2 mm ABS carbon black. So but based on our application, we can make the structure. Even we can make a lightweight structure also for doing this EMI shielding applications. So these are the limitations of the research work. One thing is like the response time is 6.9 seconds, and mostly it is suitable for the steady flow application. And one more thing is like if you are using a polymer based sensor, so the glass restriction temperature is 120 degrees Celsius. So hence it cannot be used for higher temperature application. We cannot use more than 100 degrees Celsius because the nature will change, material nature will change. So normally ABS is amorphous, then the state of the material will change. So these are the scope for the future work. So this can be used for structural health monitoring system, and also we can make sensors for measuring the displacement, pressure, and temperature. So same kind of sensors we can use for checking the any poisonous gas or liquid is there. So for that also we can use this kind of sensor. And one more thing is like a latest thing I told, like a wearable electronics. We can make the sweat analyzer, those kind of things. And low cost circuits also can be made for using 3D printing. And process parameters can be optimized to improve the mechanical, thermal, and electrical properties. So these are the reference. Thank you. So if you have some questions, you can.
Yeah, but really, participants, if you have any questions, you can ask. Participants, if you have any.
Sir, actually,
have any
carbon
doubt, you
black,
can ask.
it will normally polymer will not absorb anything. Like if you are mixing with the conductive material like carbon black, so it make the composite as conductive material. So like if it is a conductive material, whatever signal we are sending, so normally it will reflect. Actually, if I am using a copper plate, so it will reflect the signals. But in case of polymer, so it is not fully conductive. So it will absorb whatever radiation we are sending, and we'll call it as observer only. Any other question is there? Sir, actually, if you change more percentage also, the strength also will reduce. We need both the strength, actually for our experiment, we have used around 15%. But previous researches I have studied, it is almost 10% only they have used. But for our application, we are only we are not looking for the structural application. So that's what I told. Normally it is available is one thing is ABS with carbon black or PLA with carbon black. So I have used a ready-made material. So normally 3D printing in FDM, they are mostly using either ABS or PLA. But ABS is having recyclability, and also it is somewhat flexible when compared to PLA. PLA is somewhat brittle. So that's why I have used ABS with carbon black.
Any other questions, sir? Okay, sir. Thank you. Thank you very much, sir. Thank you for your nice presentation.
Thank you
very much. Thank you, sir. Thank you.
Thank you, sir.
So you can sign up now, sir. Participants, please stay online. The next session by Dr. M. Malayapan is to begin. Please wait. Participants, please stay online. The next session by Dr. Malayapan is about to start. Participants, please wait. The next session is about to start. Participants, please to
Sir, 2 minutes, sir. Sir, give me 2 minutes. Actually, I'm just reaching lab. Give me 2 minutes.
Okay, sir. Okay, sir. Can you hear me, sir?
Hello, I'm audible.
Yes, sir. Shall we start, sir?
I'm audible.
Yes, sir. Shall we start the session, sir? Shall we start the session, sir? Malaipan, sir, can you hear me, sir? So shall we
Yes,
start,
sir, you are audible. Just a second. Yeah, we'll start in 2 minutes.
Shall we start the session, sir?
Yes, sir, we'll start the
Please
session.
share your
We'll start the
screen.
session.
Please share your screen.
Yeah.
Please share your screens.
So good afternoon to all. So I'm audible. So I am from Contact. So can
Please share
I?
your screen, sir.
What it is?
We can hear your voice alone.
My side, I have a noise, sir.
So we can't see a screen, sir.
Okay, I did not share the screen, so I will please wait and share the screen.
Your voice is also not so audible, sir.
Okay, one second. Okay, now the screen is visible, sir. Okay, so now my screen is visible, sir.
Yes, sir. Vehicle dynamics. We can see, sir.
Okay. So shall we start,
Yes, sir.
sir?
Yes, sir. Yes, sir. Dear participants, good afternoon. Before starting the 12th session, let me introduce Mr. Malayappan. It's a privilege to introduce Mr. Malayappan, Director of Pantech Group of companies. He holds in Electrical and Electronics Engineering and ME in Power Electronics and Drives from Anna University, Chennai. With nearly 2 decades of experience, he has outstanding contribution in the fields of electric vehicles, renewable energy, and power electronics. He successfully developed a 350 kg EV prototype, established solar and wind energy systems, and conducted 150 plus webinars and workshops with more than 10,000 participants. He has collaborated with leading institutions like Texas Instruments and ATAL. His expertise is together research, product development, and large-scale training in emerging technologies. On behalf of all the participants, I once again welcome Mr. Malayappan. Thank you, sir. Thank you very much for being here. Now I hand over the session to Mr. Malayappan. Thank you, sir. You can start your presentation now.
Okay, thank you. Okay. So today in this session, we can see the vehicle dynamics. So vehicle dynamics means before we going to design a EV vehicle. So the first topic is vehicle dynamics. So because of for EV record means main thing is 3 components. So one is a motor, so controller, and the battery. Okay. So battery selection is apart from another concept. So we can choose the motor. Okay, so vehicle dynamics is topic of choose the motor. How much power required to move your vehicle? So the topic is called vehicle dynamics. Okay, so one by one we can see how to calculate the motor power. So how type of gearbox we can select. So and also finally we can see the MATLAB simulations. Okay, so for introduction of vehicle dynamics. So vehicle dynamics is nothing but we can vehicle moves in 0 position to some speed. So first main thing means we have to move the vehicle from 0 to some speed. Okay, so it's called a basic vehicle dynamics. So how the vehicles moves on the road means we can impact under the ground and tires. Okay, so impact under the forces. So we can arrest the degrees of freedoms. So we can move the vehicle. So according to the Newton's second law of mechanics, how much power required to overcome the 0 position to some speed. So that is the main thing of vehicle dynamics. So next is what are the forces acting along the vehicle? So the vehicle moves in 0 to some forces. So what are the forces acting on the vehicle? So totally the name is called total tractive force. Okay. So total transport have the some difference. So amount of total traction parallel to the direction of the motions. So these are the split ups. So first one is rolling resistance force. So second one is aerodynamic force. So third one is a grading resistance. So fourth one is the acceleration force. So acceleration force have the 2 split ups. So linear acceleration and angular acceleration force. We can see one by one. So what is that? These are our forces. So total name is called total tractive force. Okay, so we have a subdivision of topic is rolling resistance, aerodynamic drag, radial resistance, and the acceleration force. So next one is rolling resistance force. So rolling resistance force is nothing but a force between ground and the tire. So because of vehicle did not fit on the tire road. Okay, so tire we can contact with the road. So what are the forces acting along the tires? We can to overcome the 0 to some speed. So we can overcome the rolling resistance. So rolling resistance is nothing but we have the odd primary surfaces caused by the IC's loss. Okay, so IC's caused the asymmetric distribution of ground reaction forces. Okay, so the forces we can go into the ground force reaction. So slightly the name is called total power equal to mass into gravity. So here the P equal to M into G. So M is nothing but mass of the vehicle. So mass of the vehicle means how much weight you can design your vehicle. So without driver humans, so vehicle body only. So we can assume only the weight of the body. After that, we can add the human weight also. So next one is gravity. Okay. So here we can, on the tire, we can access only two forces. One is normal force. Normal force nothing but a gravitational force. So another one is traction force. So traction force is opposite force. Okay. So here the rolling resistance moment is formula taken power into A. So already we can know power equal to mass into gravity. Okay. So here we can substitute the force required given formula means so F equal to T by R by D. Okay. So force formula equal to TR by RD. So what is the rolling resistance moment? TR means P into A. Okay. We already know P into A. So A is acceleration. So we can P into A means you can substitute the RD. So RD rolling resistance. So RD nothing but rolling resistance. So RD is nothing but rolling resistance. So RD equal to P into FR. So R equal to P into FR. FR nothing but so we can put the RD in outside. So TR go to inside means equal to P. So dot FR. So P equal to total power. So total power means mass into gravity. So FR is the rolling resistance coefficient. So FR is nothing but rolling resistance coefficient. So now the formula derived from rolling resistance force. So rolling resistance force mass into gravity into rolling resistance coefficient. So this is a rolling resistance formula. We can calculate the rolling resistance. So mass into gravity into FR. So we not understand means we can give the examples of that time we can understand very easily. So this is how the formula we can get. So that definition I can give. So but the rolling resistance formula means FR equal to M into G into FR. Okay, so M equal to we already know. So G we already know constant value. So FR also we can get data from the Google. So we can type the coefficient value means they are given. So coefficient value is nothing but so depending upon the tire materials road conditions values. So we can fix the coefficient values. So next one is aerodynamic drag. So because of the vehicle body moves in air medium. In air medium, we can control the two types of aerodynamic drag force. One is shape drag, another one is skin friction. So shape drag is nothing but when a car move in air body means we can give the slope. So because of when car body strike the forces, that time vehicle will be reduce the speed. So we can give the curved so here we can give the curved display means the vehicle moves. So here the empty space, low pressure, here the high pressure. We can passes the high pressure air to low pressure area. Okay, so that is a shape drag. So because of its strike means here the high pressure area, when air flows through the slope of high pressure area to low pressure area because vehicle moves in moved means that the area is a low pressure area. So vehicle high pressure sent to low pressure area. So next one is skin friction. Why we can take the skin friction means so vehicle air touches the car body. Okay, so because of air strikes the body, that way we can take the skin friction. Okay, aerodynamic drag. So skin friction formula equal to half into rho into CD into A into V square. So half into 0.5 value. So rho is the air density, kg per meter square. Sorry, meter cube, kg into meter cube. So air density means we can design for India. So air density value is 1.250, I think it's outside. So we can design the north side means we can 1.8, I think. So air density. So air density will be vary because of air density. So we air density vary means we can take the air density value. You designed for vehicle in south side means we can take on the 1.250. You design the vehicle for another countries or wherever means we can take that density values. Okay. So next one is area. How much area we can need to design the car? Okay. So as a designer, we can take the values. So how much the frontal area in meter square? So CD is a drag coefficient. Okay. So here the drag coefficient nothing but shape. So we can give the straight line means drag coefficient value is very high. So we can give the slope means so drag coefficient will be low. So it is a drag coefficient. So that also we can take from the Google. So V is the velocity of vehicle. So substitute meter per second because of unit change. Okay, so force means Newton. We can substitute kilometer per hour means we cannot get the Newton. So we can get the Newton means you want to substitute the value in meter per second. Okay, so vehicle of the velocity means how much speed you can reach. For example, 40 RPM means you can reach the here the how much speed, so not the distance. So here the velocity of means how much speed you can achieve in the your car. Okay, for example, 80 kilometer, 90 kilometer. So if that data given by the kilometer per hour, so we can convert into kilometer per second. Okay. So next one is grading resistance. Okay, so grading resistance nothing but when a vehicle drive in slope condition. Okay, so hill station or slope condition means a vehicle will be climbed in inclined position. That the time the force acting on the downward direction only. So when a vehicle drives in upward direction or downward direction, whatever the direction. Okay, so two forces acting. So one is a downward force or gradually always acting in the downward direction. So another force acting on the slope condition. So in mechanics terms, we can acting the two force means we can split the force in two direction. Any force applied on the inclined direction means we can split into two directions. So like that means m into g into sin theta, m into g into cos theta. Okay. So because of output in the upward direction, downward direction, it can be negligible. So only slope force we can take. So that is a formula equal to m into g into sin theta. Okay. So here the theta is nothing but slope of the value. So here the theta is nothing but slope of the value. Okay. So this force is not required too much. So if you want to vehicle drives in hill areas means we can consider the grading resistance. But otherwise your vehicle running in normal road means we cannot consider the grading resistance. But your vehicle drive in any slopes or any hill station means we have to consider the grading resistance. Okay, so here the formula equal to m into g into sin theta. Okay, so now we can come to total tractive power. So formula is total tractive force into velocity. Okay, so what is meant by total tractive power means? So sum of the forces is called the total tractive force. So sum of these forces. So sum the four forces. So here, so sum of these four forces: rolling resistance forces, aerodynamic drag force, so grading resistance force, acceleration force. Okay. So here give the example. So half into rho into c into a into b square. So like that, sum plus mass into gravity into F or sum plus mass into gravity into sin theta. Okay. So sum of these forces is called the total tractive force. Okay. So here the acceleration force. So because of we can not drive in same acceleration. So depend upon the condition, we can changing the speed. So speed changes means acceleration also changing. At high acceleration, okay, so force is high because that means acceleration also high. At low acceleration, forces will be also low. Okay, so the acceleration is not constant, maybe vary. So you have drive in highway means you can reach the 100 kilometer, 200 kilometer. But you have to drive in city means we cannot within limit 40 kilometers, 50 kilometers per hour. Okay, so force will be vary, so acceleration will be vary. So the force exert the object is equal to mass of. So the formula is force equal to mass into acceleration. So m into a. So here we can extend the linear acceleration is equal to formula equal to mass into acceleration. But you can extend slope acceleration means you have to integrate the power. Okay. So whereas acceleration is dv by dt. So energy comes out of the vehicle of motion in. So integration of total tractive force into dt. Okay, here the dt into time. So we can see the one by one next in slide. So the total energy you can find means integral of p track into dt. Okay. So here the 5 to 10% of linear acceleration will be the angular acceleration. So nothing but we can give the extra acceleration. So vehicle will be climb up the slope also. So that is the difference. We can give the, so for example, we can give access in linear, we can give the small values, but you can give the high accelerate means the vehicle will be riding slope. So that's a small values. But concept is 5 to 10% of linear acceleration will be the angular acceleration. That is a output. Okay, so next one is the vehicle driven by the motor power through the gear means we can use this formula. So power equal to torque into omega. Okay, we can use the vehicle driven by the gear. So the motor connected to the gearbox. So gearbox connected to the differential unit. So unit drive the vehicle. That means we can use this the formula. So power equal to torque into omega. So speed of the vehicle omega equal to torque into velocity by radius of the wheel into gear ratio. Okay, we can drive the vehicle through gear means we can use this formula. So without gear means you can directly substitute the formula, another formula. So we can revert with gear means you can go with these values. So final means to find the critical velocity of the above equations. That means critical velocity. Critical velocity is nothing but so how much power required to move the vehicle 0 to some speed. That time, how much time we can take up. So how much time the vehicle will be pick up. So it simply says how many time required to pick up the vehicles for seconds in 10 seconds or 20 seconds. How much speed it will pick up. So that is called a critical velocity. So we have the formula in MATLAB. We can explain next. So here the basic formulas. So power equal to torque into velocity. So here the unit of power watts. So torque Newton per meter. So velocity radian per second. So omega formula is normally one omega formula. So that is derived from the mechanical term. So rotational part of non-mechanical rotation. We have any calculate the rotation value means so 2 pi n divided by 60. So 2 pi n divided by 60. So n is nothing but RPM. Okay, so we can get the motor data. We can choose the motor data means we can get the how much voltage, how much RPM. Okay, so we can get the data from motor data sheet. So on that RPM we can find out because of how much rotate. Okay, so 1000 RPM means per 1 minute how much rotation we can done it. Okay, we can find that formula. So 2 pi n divided by 60 is the unit. Okay, so this example sum. So we can understand which we can give the example sums. Okay, so here any doubt of regarding these topics? If there is no doubt means we can go with the example sums. So we can understand very easily. So this is a concept. If you have any doubts. If anyone have any doubts regarding the topics. Yeah, okay. So next we can thanks and so next we can go to the example sums. So if you have any doubt, means we can message chat. I will clear it. Okay. So next. Okay, so this is the vehicle dynamics calculations. So here the data of our company first developing the EV data. Okay, you can go to the YouTube, so Bantech e-learning exchange. So there is we can put the version 1 vehicle. Okay, so here the data of version 1 data before choosing the motor. So we can calculate the weight of mass of the vehicle 280 kg. So vehicle weight means 280 kg plus 300 kg for human weights. Okay, so mass of the vehicle is 280. So here we can width of the vehicle, height of the vehicle, length of the vehicle. Here we can take the area. Okay, so for data we can give the width of the vehicle, height of the vehicle, length of the vehicle. So we can take width and length. So it's called area. So we can so area equal to width into length. We can get the area value. So here, so 0.76 meter square. So here the FR value. FR value is nothing but a coefficient value of aerodynamic rolling resistance 0.013. Okay, we can searching in Google means so lots of data I can give up. So choose whatever the road surface. So rolling coefficient value choose depending upon the two. So one is type material and one is the road conditions. Okay, so compared to these two parameters, you can give the coefficient values. So coefficient values, so constantly they are given in Google's. So FR equal to here we can take in the 0.013. So air density. So air density. So same. So 1.250 kg per meter cube for south side. So we can take the air density value is 1.250 kg per meter cube. So CD. So drag coefficient is 0.300. So here we can calculate the area from the above data. So gravity, all you want to know gravity 9.81. So angle inclination, so theta equal to 6 degree. So tire radius 0.3. So maximum velocity is 90 kilometer per hour. So my vehicle of the maximum speed is 90 kilometer per hour. Okay, so these are the data. So from this data, we can find the total tractive force. Nothing but how much power required to move our vehicle. Okay, so to find power, so power formula equal to V into F. So the data derived from the mechanical term. So force equal to P by V. Okay, so total. So here the force equal to TTF into V. So TTF is nothing but total tractive force into velocity. So total power equal to total tractive force into velocity. So power, velocity, force. So we can so force equal to power by velocity. So we need the power. So total tractive force into velocity. So in the formula. So TTF is nothing but aerodynamic sum of these forces. So drag forces, rolling resistance forces, gradient resistance force. Okay, so sum of these forces means we can get the total tractive force. So we can find first aerodynamic drag. So aerodynamic drag formula is half into rho into CD into A into V square. So we can substitute. So half 0.5. So rho value 1.250. CD. So 0.300. So area 0.3 square. Sorry, 0.71. So velocity we can substitute in meter per second. So that's why you hear the unit conversions. So kilometer. So data given in kilometer per hour. So we want convert to meter per second. So how much means so kilometer per kilometer per kilometer per hour. We can substitute into meter per second. So kilometer to meter. So that value is 1000. Kilometer to meter 1000. So hour to seconds. So we can substitute two data. So hour to minutes, so 60. So minutes to seconds, so 60. So totally 3,600. So 1000 by 3,600. So this is a unit conversion method. So legal step. So how convert to meter per second? So kilometer 1000 divided by hour to seconds. So 3,600. So we can mark it. So another aptitude method is on there. So the method is 5 by 18. Okay, 5 divided by 18 means it also convert to meter per second. So you can check it also. You can convert meter per hour to this way 1000 divided by 600. So same way 90 into 5 by 18 we can get the same values. Okay. So we can multiply these values. So here we can derivative. So derivative means 2020 cancel. So 3.6 square. So after that we can divide 625. Or otherwise we can put in calculator 90 into 5 by 18 means we can get the 625. Okay. So total. So here the total drag force is 89.179 Newton required. So your vehicle in zero position. So here the 90 Newton. So round off means 90 Newton required. For your vehicle, you can reach the 90 Newton force to move 0 to some speed. Okay. So required force is 90 Newton. Okay. For your designed vehicle required force. Okay. So that are the aerodynamic drag force. So next one is rolling resistance. So rolling resistance we have to know. So mass of the vehicle is 280. So gravity 9.81. So FR rolling resistance value. So 35 Newton required. Okay. So required force is 35 Newton force to move the vehicle. Okay. So zero rolling resistance force how much means 35 Newton required. So 0 to some speed. So next one is grading resistance. Okay. So here I have mistakes. Not mistakes. Before you can using the theta value. So first you have to convert to radian per second. So directly we can put 6. Not we cannot directly put 6. So we can convert to degree to radian. Okay. So how know how to convert degree to radian? If anyone knows means you can message me or otherwise I can tell you. So degree to radian, we have to convert degree to radian. If anyone tell me how to convert degree to radian. I'll write chart how to convert just a formula. Not formula, we can just compare the value. No one is this data for car or other vehicles. So this data we can design the first version of car, that car data. Though some means we can derive the first vehicle version 1. So that the data. Okay. The correct answer pi divided by 180. Okay, so degree into pi by 180. So that is the formula. Okay, so 6 into pi by 180. Okay, we can directly calculate sin 6. So that will be answer will be vary. Okay. So how we can put means we can convert it to radian for unit conversion. We can convert it to radian. The radian value, sin radian value. So into 9.81 into 280. So the answer will be vary. So here the answer is direct 6 sin theta. So answer will be not correct. But the correct way means we can convert the degree into radian. So sin radian value. So that value we can multiply with the 280 into 9.81. Okay. So near 300, I think near 300 Newton required to overcome the gradient resistance force. Okay. So here we can sum the total reactive force. Okay, so we can find the three forces. We can find the three forces and sum of these forces. So total tractive force is 450 Newton. So 412 Newton. So round off means 450 Newton required to overcome the vehicle. Okay, so next we can find the total power. So total power is nothing but total tractive force into velocity. So total tractive force, so velocity by 90 divided by 3.6. So directly you can substitute the values. Okay, so Newton. So here the meter per second for because of unit conversion. So watts or joule. Okay, we can convert means watts or joule. So we can record the watts. So 1030 watts. Okay, so we can record the total power is 1 kilowatt. Okay, so your vehicle body record. So when your vehicle body moves 0 to some speed means your recorded power is 1 kilowatt motor. So we can choose the higher range. So what are the values we get means we can choose the higher one. Okay, because of this very efficiently, not choosing 1 kilowatt. That way we can select the power of motor is 1200 watts BLDC. So requirements or up motors. So two-wheeler means we can select up motors. Motor means we can choose the normal 1200 watts motors. Okay, this way we can choose the motor for EV. So bus also, car also, whatever. So this is a steps for we can choose the motors. Okay, so any doubt for the session? So after that we can go with another data. So any doubt? Any doubt? So we can choose the 1.2 kilowatt motor for BLDC. Any doubt? We can understand the concepts. Vehicle dynamics concept. So this is a first step to design the EV car. Vehicle dynamics. So wherever we go study, so first step is vehicle dynamics. Okay. So how much power required to choose the motors? So motor we can choose motor condition, we can choose the batteries. If there is no doubt means we can go with the next step. So we can find the total power and what is the motor rating we can get. So 1.2 kilowatt motor we can choose. Okay. So if everyone understand, we can go to the next section. If anyone will reply me, we can go to the next section, next topic. So next topic means next step. So here the motor specification. So now we can design the motor for 1.2 kilometer. So we can get the 1.2 kilowatt motor. So for the 1.2 kilowatt motor, so taken from the Google sheet. So what type of motor I can choose? You can data from the motors. So what are the data you can record means? So motor name, so that might not matter. So voltage, so 48 volt. So operating voltage is 48 volt. So rated power 1200 watts. So rated speed 3000 RPM. So maximum torque is 20 Newton meter. So these are all data we can record to design the next steps. Okay, so we can choose the motor. So motor coupled with the differential unit. Okay, so motor coupled with the differential unit. So here also we have some gear setups. Okay, so the name is called sun gears. So here we have the gears also. So front and back, you can choose to front and back direction. So okay, so here the formula. So we already know So power equal to torque into omega. Okay, so omega is nothing but velocity. So already we can know. So omega equal to 2 into pi into n divided by 60. Here the n. So I mentioned the RPM for understand. So 2 pi n divided by 60. Because of we can find the single rotation. How much time to take for a single rotation for 3000 RPM means. So total 3000 RPM for the seconds per second. How much time taken for a single rotation? So that way we can find. Okay, so 2 pi RPM, so n divided by 60. So we can substitute 2 into pi into n divided by 60. So here the omega equal to 314.159 radian per second. Okay, so this is the maximum torque of your motor. So we can choose that motor. So this is a maximum power. So 314.159 radian per second. Okay, so the vehicle is driven by the motor through the gear. Okay, I already told you. So gear. So we can select the speed of the vehicle, velocity. So velocity radius into gear ratio. Okay, this is a formula. So power equal to torque into omega. So here we can find the velocity. Okay, so we don't know the velocity. So we can find the velocity of the motor. So power equal to torque into V by R into G. So here we don't know the V. Okay, we have to find the V. Okay, we can know the power. We can know the power of motor, 1200 watts. So here don't know the velocity. So we can find the velocity. Velocity is pickup speed. Okay, how much we can reach the pickup speed. Okay, in 2 meter per second. Okay, that's the answer. So how we can find means. Okay, so we can know the torque value. So P equal to torque into V by 0.3 into 9. So P equal to torque into V into we can inverse. So 9 divided by 3. So 9 divided by 3 means we can get the value 30. So we can find the velocity. So V equal to P by T into 30. So V equal to 1200 divided by torque value 20 into 30. So we can derive means we can get the 2 meter per second. Okay. So the motor will be time taken pickup for RPM. So you take the 2 meter per second value. 2 meter per second value. Okay, so this is the critical velocity of the motor. Okay, so this is the critical velocity of the motor. We can find the two acceleration here. Okay, so here there are two acceleration here. So initial acceleration is t equal to t max. So we can take the 20. So another one we can so we can take the two equations. Okay. So here the NQ means nothing but efficiency. So efficiency of the motor. So G is the gear ratio. So 9:1, 8:1. So gear is nothing but how to choose the gear ratio means 10:1, 9:1, so 12:1, 14:1. So nothing but we have to choose the direction. So 14 gears, 14:1 means 14 gear runs in one direction, 1 gear rotation reverse direction. That 9:1. So 9:1 means 9 gears run in first direction, 1 gear run in reverse direction. So the gearbox is ratio. The name is called gearbox ratio. So how we can choose the ratio means ratio. So 9:1. So 9:1 is nothing but 9 gears run in same direction. So 1 gear run in opposite direction. So that is the meaning. So R is the radius of the wheel 0.3. So T max is 20. So here they are the same formula, aerodynamic drag plus the 0.625 is nothing but aerodynamic drag, rolling resistance, aerodynamic drag. So here the radial resistance. Okay, so M into IG square R and Q nothing but moment of inertia. Okay, so it is nothing but moment of inertia. So we can integral the dV by dt. So moment of inertia means nothing varying concept. We can derive the too much time. So in this time is not enough to use the moment of inertia value. So just we can give the 320 value. 320. So if you have any doubt means you can get the course. That the course you can explain the what is moment of inertia of the designed vehicle. So we are get from the area. Okay, so moment of inertia depending upon the area. So I have another formula. Okay. So this is nothing but moment of inertia dv by dt. Ig square nothing but moment of inertia, mass sum plus Ig square to moment of inertia. So R is the same thing, radius of the wheel, nq is the efficiency. So dv by dt. Okay. So total value is 320. So we can substitute all the values. So one by one we can derive. How to derive it means first we can simplify this area. So the value is 534. So next we can simplify this area. So 35.79. So next we can simplify the drag. So 0.652 into 0.3 into A into V square. Okay. So we can constantly fix the V square because of we don't know the velocity. Okay. So what is the critical velocity of the vehicle? So we can fix the V square is constant. So dV by dt. Sorry, one second. Sorry. So 320 dV by dt. Okay. So next we have to simplify this equation. So one by one we can give this side because of v square we can put in one side. Okay. We can find the dV by dt. So constantly we can find the dV by dt. So we can one by one we can send this side. So 534. So this side we can simplify means so 534 minus 35.70. So here the value. So next step means okay, we can also send this side. Okay, so we can also send this side. So 498 minus 0.1268 v square. So dv by dt. So after that, so into 320 into dv by dt. So this side is divided. So 498.2.2 divided by 320. So here also divided by 320. So total dv by dt equal to 1.557 minus 0.0045 v square. Okay, so this is we can consider as the equation 1. So now we can find the dynamic equations. Okay, so dynamic is nothing but how much torque produced by your motors, chosen motors. Okay, how much torque developed. So for 1,005 watt means how much maximum torque produced by the motor. We can find the dynamic equation. So same formula, torque equal to omega. That time we can find the torque also. Same formula, but we can find the torque also. So here we can give so P equal to T into V by 0.3 into 9. So P equal to T into V into 9 by 0.3. So T into to simplify 30. So we know the power of our motor, so 1200 V into 30. So torque equal to 40 by V Newton per meter. So this is a maximum torque produced by your motor. Okay, so this torque we can substitute equations to. So that equation is called 2. So this is a dynamic equation. So NQ G by R into T max. So same formula we can same way we can derive. So we can V only put it. So we have the 2. So one is T. So another one is V square. It is the equation. So we have to find the dV by dt. So now wait, I open the MATLAB and I sharing the screen. If any doubt means you can check. So now we can simplify the equation 2. So we have the program for this simplify. Okay, so I will show one after opening the MATLAB. Now, okay, my voice is audible.
Yes, sir. Your voice is audible, sir.
Yeah, okay.
Screen sharing is not there.
Sir?
Screen share is not there. Sir.
Okay, okay, sir. No, sir, no, sir. Open the Mac
Okay,
lab,
sir.
no, sir.
Okay, sir.
Okay. So this is a program. Okay, we can see we want to what is the values. We can change the values. Okay, 1 second. So this is a formula. So basic formula, so nothing but we have to put these values here and here. So for example, so go to value. So here in equation one. Okay, so 1.557. Okay, so we can give the 1.557 here. So 1.557 here. Okay. So V square formula we can given here. So what are the values given? 445 V square. Okay, here 445 V square. So this is a equation one. We can enter the equation one here. So 1.559. So 0.00445 V square here. So next we can enter the this value. Sorry, equation two value. Okay, so 3.33 divided by V. So we can see so 3.33. So here the value is 3.33. So 0.1158. 0.1158. So what is the final value? Same 445. Okay. So here we can label the time. So we can block the output. So we can just run the simulation modes. We can get the output. So this is the velocity. So this is time per second. So this is a critical velocity. So what is our motor critical velocity is 13.2. Okay. So for 1.2 kilowatt motor, so the critical velocity is 13.2. So time is near 13 second, I think. Period also 13. Okay. So the critical velocity. So critical velocity is so time is 13 seconds. Okay, so for our motor, so 0 to some attain the some speed is 13 second. Okay, in this way we can find the critical velocity of one motor. Okay, so final equations. So here we can find the time. So these are final equations. Okay, so we can already 30 seconds as the pickup speed. So 5 to 10% of linear acceleration will the angular acceleration already we know. Okay, so we can know the power work done formula. So power work done formula is nothing but total power equal to work done by time. Okay, so what is the work done by formula is half into mass into velocity. Okay, so work done is half into mass into velocity. So we have the values, so half mass value, velocity also know. So now we can know the time also. Okay, we can substitute half into so mass of the vehicle. So 93.6 square divided by 13. So 8,000 by 30. So total power record. Okay. So total power record means 6,730 watts. Okay. So this so we can choose the 6 kilowatt battery. So, okay, so total power required means 6 kilowatt batteries. Okay, so how to choose the battery means you can choose the 6 kilowatt battery for the motor. So total power. Okay, so how much total power required means 6 kilowatt total power we can record to move your vehicles. Okay, so this is a vehicle dynamics. So have any vehicle dynamics doubts? Or any other doubts? So now we can create the MATLAB that I'm asking. So theoretical part is completed. So now we have to go to the MATLAB simulating. If you have any doubt means you can go to the MATLAB. There is no doubt means. So if you have any doubt means you can ask. If you have any doubts, it's all playing in vehicle dynamics. If you have any doubt regarding vehicle dynamics or any other doubt, so ask. Yeah, next we can go to the MATLAB simulations. Before going to the simulations, anybody have the doubts?
Hello, sir.
Yes, sir. Yes, sir. Yes, sir. Tell me, sir.
See, what is G gear ratio? How do you choose that value of 9, sir?
9:1 ratio gearbox. So that we can choose the basic model gear ratios. 9:1.
Oh, standard value you have taken.
Oh, yes, yes. Yes, yes, yes. 9:1 basic model we can.
Is there any difference between gear ratio and the velocity ratio?
Which velocity ratio, sir? I did not understand. Gear, we have the gear ratio, we can change. For car, we can use the 6 to starting is 6:1 for car. So small car, we can use the 6 ratio. So higher end car, we
Okay.
can use the 11:2 ratio. So
Yes,
depend
sir.
upon
Yes,
the
sir.
car, ratio will be vary.
Yes, sir.
That's all.
There are two terms are there. One is velocity ratio, somebody told. Another one is gear ratio. Is there any relation between gear ratio and velocity ratio for designing the gearbox and all? I am asking.
No, sir. Gearbox design is there is no comparison between velocity and while running the vehicle, means we have a comparison. While through gear, we can run the vehicle, right?
Yeah, yeah.
When
Yes, sir.
the
Yes, sir.
when give the acceleration, the concept is when give the acceleration, sir, acceleration pedal.
Yeah, yeah.
So
Yes,
that
yes. That is
yeah.
understand, sir. But one of the slide you have put to that inclination 6 degrees something, if I'm right.
Oh yes, yes.
It,
The value 6.
it's that kingpin inclination.
Oh yes, sir. Yes, sir. Yes, sir. Maximum degree is 6 degree.
Kingpin inclination.
Oh yes, yes.
Okay. Irrespective of that dimensions of the.
Your voice is breaking, sir. Hello, sir.
Sound. Okay, sir. Thank you, sir. Thank you.
Oh, thank you. Thank you. Now we can go to the simulation part. The screen is visible, sir. Okay, so the screen is visible, right? So everyone know the MATLAB, right? So using the 2021. So this library browser. So all the parameters inside the toolbox. So what are the parameters? So we have to make the vehicle dynamics block sense. So UAV tools, so whatever everyone, so update version. So 2024 still, we also designed the flight simulation also inside the MATLAB. Okay, so I use Windows 21. But the update version means you can design the flight simulink also. So all the block sets inside the libraries. For update version, we can know the block name means we can double click, you can get the block also. Okay, so I know the components blocks, so I can use double click way. So first one we can take the vehicle dynamics block. So not vehicle dynamics, so vehicle body. The name is called vehicle body. So double click the screen. Okay, asking the search option. Again, workspace area. We can double click means asking the name. We can just search vehicle body. Sorry, it's my side is error, so memory loss error. Create, but we have the already defined module, so I can just explain that module. If work means I can create the body setups.
Sir? Sir?
Yes, sir. Okay. Okay. So now visible, sir.
Yes, sir. Visible,
So
but
this is the simulation.
simulated.
Yes, sir.
Voice is
Simulation.
also not audible.
Now okay, sir. Sir, now
Screen
okay.
is not moving, sir. Screen is not moving. It is the same.
Now okay, sir.
Yes, sir. Now only. Yeah.
Yeah, okay. So this is the simulations of basic EV model. So I give you overall view. So after that, I can explain one block. So here the battery. So here the battery is a system. So there is a PW generation. So where out the PW generation. So we can connect the motor here, DC motor. So normal DC motor we can connect here. So through the DC motor we can connect the gear systems. Okay. So how to convert the gear speed using group signals? So for mode change. Okay. So next year the sensor, torque sensor, how much torque required to drive the vehicle. So we can take the value from torque motor. So here the brake systems. Okay, so here the brake system. So overall the vehicle body dimension here. So here the overall option means how much speed and distance covered by your vehicle. So depend upon the battery capacity and the vehicle body weights. So that is the simulation output. So we can open the this block means. So have to create this block. Okay, so I have the problems. The problems memory loss error. So I cannot create the new model. So that way I explained the already designed model. That is the problem. So sorry for that. So I just explained this name and the block everybody. So have the update version. So after 2020, have the this block are only available. Below the 20, these blocks are not available. After 2020, after we can available all the blocks. So have any 2021 blocks means you can try it. So I knew the one by one blocks. So this name is vehicle body. So it is nothing but so body of the your car or not also the in block we have the vehicle body. So we went double to the vehicle body means we can enter these parameters. Okay, for example, what are the data given the vehicle dynamics? All the data you can enter here. Okay, so ask there is the mass of the vehicle. So mass of the vehicle means so 280. So here we can give the plus passenger also. So not only the vehicle body. So vehicle body means enter the all the total weight of your car. Vehicle body, extra accessories. So how much weight means we can enter the 8 here. So 280. So passenger 3 members. So 100 means 300. So I give the 300 weight. So the overall the vehicle weight is 580 kg. So axle number of axle means one axle. So we can drive in one axle. So backside one. So we can give the distance from center. How much distance we can from the center we can have enter. So horizontal distance from CG. So CG is center gravity. So center from front how much distance. So center from rear axle how much distance. So what is the ground clearance? What is the ground clearance of your EV? So all the data we can enter here. So gravitational force, so 9.81. So here we can enter the drag, aerodynamic drag. Okay, so just area of your the car. So drag coefficient, what are the value you can coefficient? So coefficient value 1.250 kg per meter cube. So we can enter the drag value here. So next one is pitch dynamics. You want the pitch dynamics means you can give. Okay, so we have used the suspensions. So suspensions data we can enter here. So I don't need to enter the value. So I just put the pitch.
Arthur?
Sorry for disturbance. So tower problem. So sorry. So network issue on my side. So okay. So explain this block. Yeah, pictures. So initial target is nothing but, so if you want the initial velocity means you can enable the initial velocity. So give the what is the initial velocity. So for 10, 20, so whatever initial velocity we can give that. So these are all data we can give to the values in the vehicle body parameters. So here there is no okay. So here the auto apply. You can change the value, just close means automatically block, take the values and close. So in update version. Okay. So next one is the tires. Okay, so this is a tire magic formula. So here the tire magic formula. So here we can give the coefficient values. So these are the constant values. So don't change. So just we can give the geometry. Okay, from the geometry, we can give the rolling resistance value here. Okay, if you want to change unit means you can change the units here. So whatever look we can change this. Okay, so rolling radius. So what are that tire radius? So this so for example, 12 means 12. So tire in inch. So you can data in inch. So you can give the inch means you can 12 inch or 4 inch whatever they can give for tire radius. So next is rolling resistance. So here we can give the constant coefficient values here. Okay, so we can give the coefficient values of rolling resistance. So FR. So dynamics, if you want the inertia means you can initial the inertia, give the values. No means you can just give as per what are the values. Okay. So this is the tire values. Just close, okay. So now here, so we have nothing but, so H is the hub. So we can connect with the vehicle body. So NR is the rear axial. So rear connections to here. So NF is the front axial. We can connect the F. So R to R. So V is the output of the vehicle body. How much velocity we can driven by the vehicle. We can see the output here. So W is the radius. We can give the what is the wind velocity. Okay, so we have given from outside. So that is the block will be given. So the block is nothing but a connection block. So we can give the data in outside of the system. Okay, so next we can give the sensors. So ideal torque sensor, how much torque developed by here. So we can see the here. Okay, so here the parameter is nothing but, so N is the connection. So H is the hub. So where is connected. So S is the slip angle of tires. So A is the values. So where we can get the values from A. So this sensor is ideal force sensor. Okay, so this is the ideal motion transitional motion sensor. So this motion sensor we can get the values. Okay, how much speed we can run. So how much distance we can cover by the vehicle. So this data we can get from the ideal motion sensors. So this is inside of the subsystem of vehicle body. So inside of the system, we can vehicle body. So wind, we can give the wind value here. So P is constant. Okay, so in Simulink, we have the two components. So one is Simulink components and the Simscape components. So Simulink component means so black color. So Simulink, so black color are the Simulink components. So black color. So brown color components are stable components. Green colors are moving components. So color definition we have seen. So these are Simulink blocks. So these are all the Simulink blocks. We can convert the data to Simscape block to Simulink block means we have used one converter. So the converter name is called a PS connectors. So you can double click. So search PS means you have the double click. You can search the PS means you can give. So PS to Simulink. So similar way, Simulink to PS also available. Okay, so PS to Simulink converter also available. So same way. So the parameters Y used means we can convert the data from Simulink blocks or Simscape block to Simulink block. So these are the connectors. Okay, so because of its scope, we have only other Simulink only. Okay, so this is a PS constant. So directly also constant block. So directly we can use the decline. So wind is the wind value. So terrain is nothing but slope value. So terrain is nothing but we can give any value in slope means we can give in PS constant. So we can connect the brake pedal. So front axle and the rear axle we can connect the brake pedal. So before that, you have to give the two outputs. So kilometer speed in kilometer per hour. So how you get this kilometer per hour. But convert meter per second means we can use the block to convert the meter per second. So distance in meter. Okay. So next one the brake system. So we have to get two axle, front axle and the rear axle. So here we can connect the two axles. So rear axle and the front axle. Okay, so the axle connections. So these two connection is shown in this side. So rear axle we can connect the brake. Okay, so this is the brake front brake. So this is the disc brake. So this block name is loaded contact rotational friction. Okay, you can move to change. So we can use as a brake. So we can apply the pulse. It can be attained. So it brake will be applied. So in the simulation, we cannot not apply the constant simulation. So we can give the time, which time we can apply the brakes. So that time brake will be applied. We can base upon the time we can give the pedal. So same block only. So we have no change to changes. So the block name is loaded contact rotational frictions. So you can search loaded contact rotational frictions. So we can connect the output connection to the vehicle body. So we can get the pulse from step block. So step block is nothing but so step block is using for so one time we can generate the pulse means we can use the step block. So only one time. So it will be on and it will be off. Okay, so we understand concept means so this is the time. So in the simulation running 100 second waits. So 75th time it will be on. So 0 it will be off. That time only the on. That means when pedal the brake at the 50 seconds and 100 seconds we apply the brake. So front brake. So rear brake means at the 50. Okay, at the 52. So 200 is not exact value. So 52, 70, 52, 70. So apply. Okay, so that time we can apply the rear brake. So time. So vary from start and vary to end. Okay, so 0 to 100. 0 to 100. We can apply these two brakes. So front axle brake and the rear axle brake. So this from connection from the step block. Okay, so this is sensor how much we can create. So next one is the gearbox. Okay, so we can use the two simple gear, so front and back. Okay, so gearbox. So here the operating three modes. Okay, here the command logic. We have opposed the three modes. So one is first gear is low mode. So second one is mid mode. Third one is high mode. We can operate in three modes. Okay, so the command from the group signal. So we have running in time basis. So our total simulation time is 100 seconds. For first 20 seconds, first mode will be enabled. So after that, so 20 to 40 seconds, second mode will be enabled. So third mode will be enabled. So this block are go to block from block. Okay, so we can give the one simulation block. The input means we can get the another subsystem block to go to from block. So here the go to block, here the from block. What are the value? If the input, we can get the output from block. Okay, so what are the input from the go to block means we can bring from the output. So we can click the mid means. So here the mid, here the actuator. So this act like the actuator. Okay, this is nothing but it's a switch. Okay, when value will be coming, you can compare the value. That time it will be acting. That's all. Okay, that block is named as switch. Okay. So we use the constant block. Sorry, we can the constant block. We can compare the values. Okay, so compare the values. That time we can be enabled. So this block is a disc friction clutch. Disc friction clutch. We can connect the B in all same connections. So we can connect the input value P in three modes of operation. So output connected to the gearbox. Okay. So this is a moment of inertia. So this we can use the motor pressure block inside the gearbox system. Okay. So here the group signal. So group signal nothing but we can automatically we can change the not automatically. Which time we want the signal mix, that time we can create. We can create the multiple group signals, square pulse, rectangle pulse, triangle pulse. We can create it. Use some time to create the signals. Already created. It is loading. Yeah. This is a signal builder. So it is nothing but we can create the step. So on and off condition. From 0 to first 10 seconds, it will be drive in first mode. So low mode. Okay, we can create the signal 0 to some time for 10 seconds. So 0 to 10 second, we can drive in mode 1. So low gear. So after that, after 10 second, we can increase to second mode. So second mode is something, but we can change the speed to second. Okay. So then from 10 second to 20 second, we can drive in second mode. Okay. For third signal from 20 to 30, we can drive in third mode. So third gear is short mode. So first gear, second gear, third gear, we can split it to seconds. Okay. So we want to 20 second means you can just drag. So point is selections. So another only play getter. So you can just move the point. Okay. So that's why we get a signal 2. So no need of signal 2 here. So only one signal. So this is useful for creating the signals. Okay, so only one is enough. So we can connect to the DC motor. So it is a DC motor. So just we can connect it. Okay. So for DC motor, we give the parameters. So which type we can, what is the wounded type or permanent type. So rated speed or no load speed. What is the index which we can change? So no load speed is what is the maximum RPM, but loaded speed is what is the maximum RPM. So what is the mechanical power? So where is the voltage? So these are value we can give from electrical type. So mechanical side we can give the inertia any damping attached. So we can connect the damping from damping here. So we can give the values. Okay. So we can search DC motor means it mark when you go from DC motor we can give the mechanical rotation reference. One point we have to connect. So this is the solver configurations. Okay, so this block we can compulsory use it for to run the simulation. So solver configuration. So f of x equal to 0. We can compulsory connect it. Okay, so this is a header file for our motor or any of these. So this is a header file. Solver configuration you have to connect. So here to the ground we can connect it. So how we can create the pulse? So we can hear the starting pulse. So 20. So initial 0.75 seconds. So finally 0.9. So this is starting. So you say the duty cycle the concepts. Okay, so duty from come. So this is a P saturation point. So P saturation block. So this is a product blocks. So this is a current voltage measurement block source. Okay, so current voltage source. So current sensor. So how much current we can travel into. So we can use the current sensor. So same voltage sensor. So voltage measurement. So how voltage we can pass through the motor. Okay, so we can use these blocks. So final So battery subsystem block. So we can use the cells. So inside the battery, so what are the battery? So inside means we have the cell only. Okay, so lead acid batteries or lithium ion batteries. So also inside the batteries we have the cells. So cell we can connect the series connections or parallel connection to make to the battery. So the basic concept means all the cells. Okay, so for example, one cell is so inside we have the one circuit, DC voltage circuit. That's all. So what is the maximum voltage? So 4.2. So nominal voltage is 4.2. Okay. So output of the cell is 4.2. So 4.2, 4.2 we connected in series. So 20% we can start connecting in series. So all cell is 4.2. Okay. So this is the circuit of inside the cell. So we make the subsystem. So give the cells like that. If want more means you can add. So how we can connect it means single cell. So nominal voltage. So convert into pack. So the process. So how we can get the pack means single cell voltage. So for example, 4 voltage means we require 60 volt means. So we first we can connect the series connections. When connect the series means voltage will be increases, amps will be constant. So we can connect in series. So 10 cell we connect in series means. So it's called a module. So 10 cell connected series connection is called a module. So another set 10 select 10 cells in series connection that's called a module. So these two modules connected in parallel. Okay, that will be increases. Its name is called a pack, battery pack. Okay, so we can connect the cells in series conditions. Okay, so the simulation depending upon the battery subsystem we can drive. So simulation, so 100 times, so I run the simulation. So while compiling, so after compiling, it will be run. Okay, so as per data, so maximum speed is 41.6. So distance covered is 1000 kilometers for the data. You can change the data means you can get the areas also. So now we can see the graph. Yeah. So this is a scan package. So gradually increase the distance. Okay, so 0 to some distance normally. So here you can see. So for first 10 second, it will be drive in first condition. So it will be drive in second mode. So increase the speed. So to third mode. Okay. After that, we can apply the brake in 15 seconds. So here the 40, so 50 seconds. So 50 seconds, we can apply the brake. Okay, so apply to 70, 75, applied here. So after two front brake will be applied. So gradually reduce the speed. Okay. So when you apply the brake here, we can apply the brake, it will be reduce the speed. So next we can apply the front brake. So first we can apply the black brake 50 seconds to 70 seconds. So here from 70 seconds to 100 seconds, we can apply the rear brake. So speed will be reduced. So this concept is so we can use the modes to increase the speeds. So that's all. So you have any doubt? So regarding simulations or EV, we have any doubts? If you have any seen hardware mark means, so you have to go to the Pantech e-learning website on YouTube. So there you post the videos version 1 and version 2. Okay, so this simulations based upon the battery pack and the vehicle body. So another one simulation is that so same. So instead of battery, we can give the tunnel simulations. So how much you can pedal the press, how much speed will be vary. So that is another concept. Per block maximum will be vary. We can remove the battery packs. Some instead of we can do the connections. That's all. Any doubts regarding simulations or EV? So whatever. So if you have any scene hardware elements, you can go to see the YouTube. Also is there. So you want to learn about more EV about means we have the course also. Okay, if you want any interest people, we can join the course and learn about a lot of things in EV. Okay, so that's all. If you have any doubt means you can clarify the doubts. If you know means we can end the session. That's all.
Participants, if you have any doubts, you can ask.
Yeah, about the EV, whatever the doubt means you can ask, not a problem. I can clarify it. There is no doubts.
Thank you, sir. Thank you, sir. It was a good session. Yes, sir. Yes, sir.
Sir, your voice is not clear, sir. Once again.
Thank you, sir. It was a good session. So,
Thank you, sir. Thank you.
uh,
Thank you.
participants,
Bye,
if
sir.
you have any doubt, please clarify. Otherwise, we can close the session.
Because future mobility is fully electric vehicles. So nowadays also use a lot of electric vehicles used in our cities. So future will be the EV mobilities. So basic thing. So today we can learn about the basic how we can start from the scratch. Okay. So the video also available in YouTube. Okay. So we also doing the projects in EV power electronics. So a lot of things. If you have any doubt means contact feel free. So any doubt means we can support for that. Okay, well, nothing problem. If you guys really interested to learn about lot of things in EV means, so we have to course we can join and learn a lot of things and also give the supports by the teams. Okay, so not only EV, so lot of educational purpose we have done it. So for any interested people, we can just check their websites or YouTube's. Okay, so get the data. So now if you have any doubts, means we can clarify it. Okay, so any doubt? Thank you, sir. Thank you for wonder to attending the sessions. I hope for 2:30 hours to spend your times. So valuable times. So thank you. Okay, so we can end up the session, sir.
Yes, sir. We can end up this session, sir.
Yeah, thank you.
Thank you
so
for
much.
your session. It was very useful, and thank you for once again, sir.
Thank you, sir. Thank you very much. Thank you to all.
Participants, our next session, 13th session, will be on title modeling, simulation, design for 3D printing, a CAD CAM CAE approach by Mr. Balamurugan. Take Participants, our next session will be on title Modeling, Simulation and Design for 3D Printing, a CAD, CAM and CAE approach by Mr. Balamurugan P. Solution expert from Petticoat Technologies and Engineering Services, Chennai. We are pleased to introduce Mr. P. Balamurugan, a solution expert with over 5 years of professional experience. He is a mechanical engineer from our prestigious College of Engineering, Guwahati. His role, he delivers product, concept, and workflow-based training to both academia and industry professionals. He also serves as chief guest faculty at the VIT Chennai and conducts FTP programs for engineering faculty. He has contributed CAD/CAM faculty at NITTR Chennai and a master trainer for Tamil Nadu Skill Development Corporation. His expertise span across leading CAD/CAM tools, including AutoCAD, SolidWorks, CATIA, NXCAD, Creo, Revit, MEP, and Inventor CAM. For his training, he has empowered numerous students and professionals with industrial relevant design and manufacturing skills. He has been continually play a key role in bridging a gap between academician and industry. Sir, Balamurugan sir, it has been very Balamurugan sir.
Yes, sir. Welcome. Sir. Yes, sir.
Thank you for
Good evening,
being here, sir. It has been a great pleasure for having you in this session. If it's possible, we can start the session, sir.
Okay, sir.
Or
Okay.
in participants, whether you need a break for 6 minutes, we can start after 5 minutes, or otherwise we can start after. Okay, sir. The session is yours, Balaji.
Okay, sir.
Thank
I will
you,
start,
sir.
sir.
I can start yours. Yeah,
Okay.
I start yours.
Okay. So my screen is visible, sir.
Yes, sir. Yes.
So first of all, I will thank to Palani sir for HOD of Adhi College of Engineering, and also I will thank to all the staff members and HOD sirs for the various engineering colleges. Today we discuss about designing and simulation for 3D printer using CAD/CAM softwares. We have already know the ideas about 3D printers, and also we know the CAD/CAM softwares like CATIA, Creo, something. Today's session we will discuss about one modeling software like SolidWorks. I create a design model and then import to the 3D printer simulation software like Ultimaker Cura. The Cura software it will show how to simulate the 3D model in 3D printers. Okay, we not show any 3D printer physical model. This is simulation only. Okay, so first of all, today topics covered already discussed. Introduction to 3D printer. So introduction to CAD modeling software. Then create one model for SolidWorks softwares. Then can go to the introduction about what is Ultimaker Cura. Then simulation of 3D printer using the Cura. And finally, we can go to the application of 3D printer. My voice is audible, sir? Sir, my voice is audible?
Sir, audible, sir.
Okay, fine. So the invention of a first 3D machine Gutenberg printing machine invented in 15th century using the brass mold. You can use this first invention of 3D printing. This is one. Then history of the 3D printing, you already know that 1880, 84 and 86, Charles helped invent the 3D printing coins. The term is stereolithography. Then 1992, next, the first 3D printer built by 3D Systems company. Then 1999, the first application of 3D printing in medical field. So creating lot of medical human bodies for the future inventions. So what is 3D printer? 3D printer is additive manufacturing, the construction of 3D dimensional object from the CAD modeling or digital 3D model. You can use any CAD model software. You can easily convert to the interface model of STL file format or STIF file format. So you can directly feed to the 3D machines. The industry then market, we have available lot of 3D printers as per your requirement. Based on your requirement, you can choose any printers. It varying the cost around 15,000 to around 1 lakh, 1 lakh to 2,000 based on your requirement. Okay, so it can be done is variety of process. Which is material is deposited or joined, solidified under the computer control, which is being added to typically layer by layer. Okay, so we'll already know the things, the 3D printer working principle. So this is an example of a 3D printer. See the medical, he have some keels alignment, so you can attach this one with the next one. So type of 3D printer. So based on the process, you can add the process. It will be convert. If you have your 4 types: SLS, selective laser sintering, then FDM. So then next one is SLA, then DLP, digital light processing. So how to use the 3D printer? Create a 3D model, prepare the import the feature, save the model into STL stereolithography file. So automatically it will be converted to nozzle mode like a G code encode. Based on the G code encode, the printer will create a model. Okay, so I can use the method for diffusing extrusions. Layer by layer, it will be adding the melting the filament. So automatically create a model. I will show the simulations. Okay, so how to 3D printing can change the world. You can use the medical processing and advanced in research, then architectural engineering and constructions, food industries and automotives, then accessories. So medical processes, custom hearing aids and human body parts like ears, hips, even organs in extra proportions in the fit the patient. Okay, in 2012 February, the surgeon successfully titanium jaw in the elder woman using the 3D printer model. I can show the model. See, this is a model. So this model processing is available in the internet. You can search and learn it. So this is our accessories, sample accessories. So how to use the CAD software to convert the model? I can open the software. This is a SolidWorks software. This is a company, is a Dassault system. So invented by the SolidWorks. So now I can create one simple model and how to convert the model into 3D printer model. Okay, using the Cura software. Okay, fine. So I can open this SolidWorks. See, my screen is visual, sir. So SolidWorks having a workflow for part assembly and drawing. So this is a CAD modeling software, one of the CAD modeling software. So now I can create one part modeling. Before that, we give some part tools. I will explain the part tools. So I can choose the part file. So it will be loading, right? Okay, listen, this is our SolidWorks workspace. First of all, I can explain some basic feature tools, and then I can create one model and import to the Pure software. So before that, you can understand what is the interface of this SolidWorks software. So this is our workspace. This is all the origin point. I want to draw any shapes, any 3D model. First of all, you can start with the 2D diagrams. So this is our ribbon tab. Here we have some features like extrusion and revolve, all the things. Then next one is a sketch model. You draw the 2D sketch. You can draw the you can open this sketch model, then draw any shape. So I can first of all I can draw the sketch. Before that, you can use the plane option. We have a plane having front plane and top plane, right plane. We have enabled to the planes. You can just right click the plane. So you click the plane, it will show visible in the workspace. You want to permanently visible means you can show the show option. So select right click the plane option, show, click the show option, it will show. So I can enable another one, see like that. Okay, so I can show all the three planes like front plane, top plane, and right plane. First of all, I can start with any one plane, like I can choose a front plane. I can right click this plane, then go to the sketch mode. So you can start with the 3D model. First complete the 2D session. So you can start with the 2D new sketch. So automatically it will show the corresponding view, front plane view. Now I need draw any shapes. So you want to remove this plane or hide this plane. You can use the remove hide. Okay. You want to some draw means, so first of all I can draw rectangular shape, so that center point rectangle. You have 4 or 5 types rectangular types will be there. I can draw a corner rectangular. I can start here the origin point here. Before that, I can enable like on the grid mode. So you know the basic CAD AutoCAD software, you know the grid options. So same like that, you have grid option in SolidWorks also. So I can draw the rectangular plane, rectangular shape. Start with here. So this is our origin point. I can draw a rectangular shape. So I can click the first corner to second corner. It will show the rectangular shape. So we can enter the dimension. So before that, you can apply the units. So you want to set the unit means you have a top right lower corner. You have a unit option. So I can choose a millimeter option. You have your meters or centimeter. You can click. So now your model having millimeter only. I can choose millimeter unit. Okay. So how to edit this dimension? Okay, I can draw the dimension roughly. So you can edit the dimension. You can go to the sketch mode in smart dimension option. select this one. I can select this length shape. Will move. Will show the dimension in millimeter. So exactly I need 100 mm. So you can double click that this dimension, automatically it will modify. Okay. So I can enter 100. So it will change in 100 mm. Same like that, you can change this width value also. I need 70 mm. I can enter 70. Will show 70. Once you complete this dimension, you can click here. So the dimension is completed. Now you can go to the exit the 2D sketch mode. So here you are using this symbol. You can click this symbol. So automatically the 2D sketch will be exiting and come to the feature window. So this is our front plane. We can draw one rectangular shape. See. So you want to disable this planes means you can use this one hide option. So only one front plane. I can draw the shape for rectangular. This rectangle I want to convert to 3D solid. So I can use the model. You can use extrusion. Okay, this is a basic extrusion. Basic. You can select extrusion. Select the 2D profile. So automatically it show the editing option. See, so the extrusion from the sketch plane. See the extrusion parameters from the sketch. I can extrude this one. I need a direction. I give the direction for this direction. Like I can want to change the direction. I can click here. It will be changing the direction of. So direction will be based on the sketch plane. Okay. Now I can enter the 10 mm thickness. You want to change means you can enter 50 mm. Okay, it will be changing or automatic manually you can move the direction also. Based on the movement, it will change in the corresponding value here. Okay, you want exact enter value, you can enter the values. I want to 80 mm, with 80 mm we will extrude. So see the direction changes. Okay, then here some types also. This is a blend option. After you can use mid plane option also. So mid plane means it will be if I can give 80 mm. Here the 40 mm from the left side of the plane and then another 40 mm for right side of the plane. So this is the mid plane concept. So which type you want to use means you can use it. But basically I can use a blend type from the side the directions. So then one more option will be there is a thin feature. You want to create any sheet metal shape, you can use a thin feature option. You can select this one. So automatically it will convert to this shape. So inner portion will be hollow. So here the thickness of the thin feature, I give the enter for 2 mm. That will show the value. Okay. Now we can use only for solid model. So I can disable this thin feature. Okay. This is our model. I can click this extrusion. Okay. This is our model. I can use the mouse in zoom out option in the center button. I hold the center button of the mouse. It will be rotating the object. You can give the rotate option. You can use the mouse. Okay. So this is for basic of extrusion. Suppose you want to remove some materials in this shape. So you can use the extrusion cut option. Okay. So suppose I can create one hole here. I can select this face. Okay. So first of all, you have your plane also. So front plane, top plane, you can use it. After completing this model, you want to edit this shape. You can choose corresponding face. For example, I need a hole from this face. So I can choose this face. Automatically it will show the editing option. In this option, I can use the new sketch. So automatically it will show the corresponding view. You can use one shortcut for Control 8 will show the corresponding view. Okay. So this is our needed plane. Now I can draw one more shape like a circular. Randomly I can draw the circular. After that I can give the dimension using the smart dimension. I give the dimension value for 25 mm. And also I can fix the dimension from the center point to the bottom edges and then left edges. So I can use the smart dimension option. I can click the center point of the circle to this edges. It will show the dimension between the circle to edges of this part. So now I need a total extrusion will be 100. I want to 50. Then left side, and also I can add the dimension for bottom side also. So I can use the same center point to these edges. select the small dimension and select the center point and select this one. It will show the values. So I need here also 50. This is okay. Fine. So I can close the dimension, then go to exit the mode, exit the 2D mode. Now it will show the 2D sketch of the circle. Okay. Now I remove this material. I can use the extrusion cut. See, our model will be removed by extrusion cut tool feature. So how much length means so how much length means it will be throughout the model, like to 80 mm it will be cut. I can click OK means I will rotate the part. See, the cut will be throughout, cut will be here. So I want some distance means you can edit this features. Suppose I want to edit this extrusion, first extrusion or edit the cut extrusion, you can easily done with this SolidWorks and CATIA or any part modeling software. It's a parametric modeling. You can go to the basic CAD means it's not possible. So here it's a parametric modeling. Parametric in the sense you can change the dimension value or you can change the geometry constraint. You can automatically adapt the part. So see, I can change the cut value. For example, I can change the sketch means I can right click and edit the sketch mode. So once I can complete this 25 mm, now I want to edit this dimension. So I can only for 10 mm means I can enter here. So automatically the extrusion cut will be adapted. See. So this is the parametric modeling software advantages. Suppose I can change the dimension again. So I need 25 only. I can double click the dimension. I can edit 25. Then I need extrusion. I can change the extrusion value or I can change the extrusion cut value. You can exit this one. So select this feature and then right click the edit feature option. So now I need only for half length for 40 mm. I can give. So it will cut only for half length of this total dimension. See, I will rotate the model. It show. See the model. So it's not fully cutted. We only cut half of the length. Okay. So this will happen in the editing option. Okay. Now I can change the basic basic extrusion. First extrusion. I can edit this extrusion. Suppose I need change the sketch or dimension value, you can easily change. So this extrusion will be 80 mm. Now I can enter 100 means 100 or I can give some 50 value. So the part will be automatically adapted. See, so the part, the main extrusion will be adapted for 50 mm, but our cut extrusion will be fully cutted. So this portion will be removed because of we can edit this model. Okay. So I can right click this one. I can give again 80. You understand? I will share. Okay, fine. So next one is you can change the sketch also. You can edit sketch mode. So I need like 80 mm or 100 mm. Now finish the mode. See, so automatically the part will be adapted. Okay, fine. The next feature is a revolve. So extrusion is nothing but you can draw any 2D profile, convert to the 3D solid model. Revolve is nothing but you can draw any cylindrical shape. You can use the revolve feature. I will explain. I can click one more file, or I can remove this file. If you want to delete this one means you can right click and delete the feature. Automatically the cut extrusion will be deleted. Then I can delete the sketch also. I can delete one. Okay, fine. So now the first sketch will be shown in the window. So I can delete sketch one also. I can delete this. Okay. So now front plane will be show. I will show. So again I can select and go to the sketch mode. So now I can draw the you can draw revolve shape. So first of all I can draw the one profile. I can use the line diagram. From the origin, I can start this line. Okay, so this is our closed profile. It will show this color effect. Suppose you can delete any one of this line is this open profile. So open profile will convert to the sheet metal part like a surface. In closed profile, we can easily create a solid part. So I can click this one. So this look like a closed profile. I can finish this one. Before that, I can use this is for closed profile. You want to you create a revolve feature means you have a two option. One is closed profile of this one. Then you have specify the revolving axis. I can enter revolving axis using the center line. So I can draw the center line along this this one. So this is a data line, show the line difference. So I can finish this mode. Now you can use the revolve option. So automatically it will be revolved. This profile will revolve using this revolving axis. So total revolving angle will be 360 degree. So it is a closed one. So it will show the profile like that. See. Suppose you want to edit the rotating angle, same you can edit option, revolving option. You can change the revolve angle. For example, I need a 180 degree. If we enter, I can click exit. So it will show the 180 degree model. Okay, I can rotate the model, it will show like that. Okay. Suppose you need to edit the sketch value means you can edit. Suppose in this sketch, I can edit revolving axis. So I can revolving axis place along this line. Now I can change the revolving axis for some distance. I can delete this center line and draw the center line some distance here. I can specify the distance. You can use the smart dimension. I need a 15 mm. So I can finish this one. So it will show the error because in revolve you can specify the axis before you can choose the profile also. Okay, for example, I can delete this one. See our sketches. Okay. Now go to the revolve option. I can select this profile. So now see the difference. Okay. So I can give some distance from the profile. There is a revolving axis. So it will show the hollow shape. See the difference. Okay. Suppose we can change the sketches like that. I can draw the center line, some distance with some angle. I can draw some angle degree. See that difference. The profile will automatically rotate this one like that. So based on the profile, based on the revolving axis, it will show the output. Okay. Suppose you can change the profile revolving axis like that. You can edit the sketch. You can delete this revolving axis. I can choose the revolving axis using the center line. I can draw this side. Okay. Now I can enter the model. So part will be, the output will be like that. I can rotate this one. One more example, I can change the line from this side, top side. This is the revolving axis. I can change the revolving axis for bottom top side. See our model. Okay, so revolve basically work for two dimension, like two features, like profile. You need a profile and revolving axis. Okay, fine. suppose we can enter the revolving axis in inside of the profile, it's not working. Okay, so our condition is the profile and revolving axis will be some distance. The distance will give the hollow shape, or you can along this line. It's not it is okay for you, but you can draw any revolving center of this line. You can draw the along this part. I can give along this part. Now okay, it will show the error. The sketch is open, self-intersecting or intersecting the center line. So this is our error. So only revolving you can draw outside of the revolving axis, draw outside of the profile. Okay, so this is our revolve feature. Then next feature I can use it. I can delete this one. I can remove this one. I can delete the revolve feature. You can delete the sketch also. So this is a loft and the swept command is disabled. Before that, you can draw any sketch, it will be show. So I can draw first sweep option. I can draw one like profile. So I can enable grid lines. So I can draw the profile like a circle with some radius. I can give the radius or diameter. I can enter the diameter for 30 mm. Now finish the dimension. This is our front plane. We can draw the circle dimension to 30 mm. Now I can choose the another plane for a perpendicular direction. So I can use the top plane or right plane. So now I can use the top plane. I can go to the new sketch, then go to the control 8 for the corresponding window. This is our circle. So now draw this top plane. I can draw the path, like a path. I can draw this point to some distance here, here. Okay, I can edit the dimension using the smart dimension option. So this is the length of 80 mm. I can give 100 mm. This is for one more 100 mm. I can finish the sketch. So we can complete the two sketches, sketch 4 and sketch 5. Now I can choose the sweep option. So I can select the sweep. So see the parameters. One need a profile, another one need a sketch 5. The sketch 5 is a path. The symbol indicate the path. This is first one is a profile. I can select the profile. Sketch 5 is a selected, already selected. Sketch 5 profile I can select. You can use this arrow and click the circle option. See the model. So like a pipe. So you can draw this shape. You can use the sweep option. So sweep having two parameters. One is a profile. This is a circle profile. Another one is a path. Suppose you can edit two sketches at any time. Based on the editing, it will be change the model. Suppose I can change the sketch mode. The sketch 4 is a circle. I can edit the sketch 4. I can use control 8. Now I need one rectangular. Before that, I can draw a rectangular shape. I can delete the circle and draw the rectangular. I can use a center point rectangular. Okay. Then I can give the dimension also. 30. Now I can finish the mode. So automatically change the model. I can rotate the model. It will show that. See. So rectangle profile will be sweep off. Suppose you want to edit this path also. So I can use same rectangular shape. Okay. Now I can change the path, so I can choose the sketch 5, then edit option. So now I can apply some fillet value here. So I can use the 2D fillet option. So I can enter the fillet value for 25, 15. So and I can finish and one more fillet arc for this corner also. I can select this two profile. We will apply same 25. I can finish this one. See the model. So I can edit the sketch 5. Okay. Suppose you can change the profile. You want this is a solid one. Suppose you want to pipe like a hollow shape, you can edit the same sketch 4. So see, I can edit this one. So you draw one. You draw the already draw one profile. You can add one more profile. So automatically it will be inner shape will be hollow. Create inner shape will be hollow. I can draw one more profile like that. I can use the offset or same circle option also. So just to draw the circle with the dimension of 20 or 18 mm. I can give 20 mm. So now finish the mode. So inner this profile will be extruded. So inner portion will be hollow. Sir, my voice is visible, sir. Sir, my voice is audible, sir.
Yes, sir, your voice is clear, sir.
Okay, fine, sir. Fine. So next one is a loft model. So loft profile. So I can delete this one. So I can select same front plane. I can go to the new sketch. Lofted profile. I can choose the feature. I can draw same two sketches will be needed. So first of all, I can draw one rectangular shape. One example, I can draw the rectangular shape. Center point rectangular. I can edit the dimension. Okay. Then I can finish the sketch mode. So I need one more sketch. So I can choose another plane. This is a parallel plane of the front plane. So you have only for front plane and top plane and right plane. So I need a parallel plane for the front plane. So I have an option for here plane option. Okay, you need another new plane. You can use the plane option. Select this origin planes like front, top, or right. You can usually you can use offset from the plane. So I can choose the plane here. That will be loading. See, I can choose this first reference for a front plane. So automatically it will show the duplicate plane. I can enter the offset value for 60 mm here. So I can click this OK. So this is our new plane. So plane 1. The name is plane 1. You want to edit the name, you can right click and edit the rename. Okay. So here this new plane, I can draw one more profile. I can choose this plane and go to the edit sketch option. I can set the view. Now I can draw the one more profile, same rectangular shape. Or I can draw circle one. .30 mm. Okay. One more plane I need. I can give 3 sketches. So minimum we can give 2 profiles. Okay. Go to the same plane option. I can click this profile. So it will be offset at the value of 80. Okay. Now I can draw the new sketch from the new plane. So here I can draw the rectangular shape like that. See, 3 sketches will be there. Now I can choose the lofted feature. So here the profile sequence, you can select this profile sequence. So I can click first plane, first sketches, like I can choose sketch 6, lofted. Then circle. Then like that. So I can use the lofted feature using the 3 sketches, like one big size rectangular, then smaller one, and then in between you can use the circle option. Suppose I can change any sketches. Suppose I need to edit sketch 7, so circle 1. I give enter the dimension of 60 mm. Automatically change the models like that. See the difference. So this is a lofted feature. So the condition of the lofted feature is you need minimum 2 sketches with a parallel plane. Okay. Then add any more sketches, you can easily draw the lofted planes. Okay. Same you can use the. Okay, next you can some modify features like a fillet chambers, then shell option, a rib feature, then some pattern option also there. I will explain. So I can choose the front plane. I can draw the rectangular shape. So I can use extrusion with 50 mm. our model. So now I can use the fillet option. You want to smooth this edges, you can use the fillet and the chamfer values. So first of all, fillet, you can use the fillet option. You can select the edges. So based on that, we have 4 types of fillet will be there. Then fixed variable and face fillet, and then full round fillet. I can basic apply for edges. So I can use the first one, the constant size fillet. This is a, you can select the edges. So it will show the radius of value. I give this 10 mm radius. I can enter OK. It will show the fillet option like that. Okay. Suppose you want to chamfer, you can select this chamfer value, chamfer feature. Select these edges. Here you have a types. So distance method, angle and distance method, or distance method. Then offset face method. First of all, I can choose angle and distance method. I can give the angle for 45 degree. Then I can give the values, distance value for 10 mm. So I can OK. It will show the result. Okay. Suppose you can use the distance method. You can edit this feature. So you can select the type for distance method. Or you can delete this feature, then delete this one. So it will be removed. So once again, you choose a chamfer. Now you can choose the method for distance to distance. Now I can enter the 10 mm for same distance. You can enter OK. It will show the 10 mm value. I can click the edges. Okay. Now show the 10 mm value. Okay. So see, this is for 10 mm. I can center the front view. Okay. So here, this is a point. So here 10, here 10. So this point will be reducing 10 mm to 10 mm. So I can vary the dimension also. Suppose so this is a distance 10 mm to 10 mm. This is a symmetric type. You can use asymmetric. You can change the dimension 10 mm to 20 mm, D1, D2 values. Suppose I can enter 30 mm. So clearly show the difference. So this is for 30, this is for 10. Okay. So this is for TO2, this is for TO. So I can change the value. It will show the preview. Suppose here 10. So first D1 will be changed for 30. It will show. See the difference. So this is a asymmetric method. Symmetric, you can enter one value. It will be applying for both sides. Asymmetric, you can vary the 2 dimensions. Okay. So I can use symmetric. I can enter the value for 10 mm. So this is for chamfer. Okay. Then you want to remove these faces. You use the shell options. I like a box shape. I can use a shell feature. So you have a 10 mm for parameter value. What is 10 mm means? I can select this face and can click OK. The face, this face will be removed. The another remaining faces are same, maintain the same distance for 10 mm. This is for 10 mm. Like I can edit this feature. It will show the 10 mm means this is on the 10 mm. For example, I can enter 2 mm here. I can close this model. See, the 2 mm means this is the thickness of 2 mm. So shell means you can remove any faces of the closed modeling, closed part modeling, or closed model. Suppose you need one more face means you can select it. Suppose you can edit this feature. Suppose you can choose control option to select these 2 faces with the maintaining of 2 mm. So 2 faces are removed. Remaining faces are maintained by 2 mm. See our model. So this is our shell feature. Okay. The next one is a rib option. This is a thin walled support solid bodies. Suppose I need some support here, I can use the rib option. So before that, I can need a rib sketch. So I can choose a corresponding plane. If this is a top one, this is a right plane. Select this one and can go to the sketch mode. I can use Control 8. Now I draw the line shape. So from here to here, I can change the visual style. You can draw the line from here to here. Now we can show the isometric view. The line will be like that. Okay. Okay. Now I can click the rip option. So I can give the rip thickness will be 5. Then I can change the direction. So this is our direction. See the direction angle. I can give OK. That will be some repo support like that. Okay. Suppose your profile like that. So I can change this rip. Delete this one. I can edit the shell option. In this bottom, you can apply some fillet feature like 10 mm radius. So it will be like that. Now after that I can apply a rip option. I can click OK. See the end of this rip part. So it will automatically adapt at the end of the part. Okay. So this is the advantage of a rip. Okay, you can draw a single line, then automatically it will be extruded, same extrusion operation. But the extrusion, the end of this part will be meet the same end of the part, it will be automatically adapted the shape. Okay, this is the advantage of rip shape. Okay, this is a rip option. The next one is go to the patterns. Suppose you need multiple rips or multiple features, you can use the patterns. You have a patterns, we have 4 or 5 types will be there. So linear, circular, mirror, we can explain 1 or 2 models. So first of all, I can use a linear pattern. So I can select this linear. So see the first of all, you can set the direction. Direction in the sense, which direction you want to the multiple bodies or multiple duplicates. You can select this one. Suppose I can select these edges or these edges. And give the distance between the two parts like 10 mm. I give the values of number of entities for 5. I can enter only 3 or 4. Select the feature. Which feature you want to create multiples. So I can select the rip option. See the difference. So the 10 mm will be show the distance between the two parts. Then 3 means count, number of count. Suppose I can increase the count, it will be increasing. Okay. So direction 2, you can change the direction mode. Okay, for example, you can change the direction here. I can change the direction, it will show like that. Okay. So I can enter OK, it will show. Okay. Fine. Delete this one. I can rotate the part. Here I can create one extrusion cut. I can draw a circle. And then go to the extrusion cut. So it will be like that. So I need multiple holes using this extrusion cut. Same, I can use the linear pattern. So the direction 1, I can choose these edges with a count of 5. Then between the distance is 10 mm. And then direction 2, I can select this edges, top edges like that. Same 10 mm between the distance, and the number of count will be 4 or 3, 4, 3. Then now I can select the feature of this extrusion cut. See the preview. So I can give enter 5 number of holes in the direction 1. So this is our direction 1. Between the distance is 10 mm. Then second direction I can give this direction using the top edges. Then I give the enter the values of 10 mm between the distance, and then number of entities for 3. Suppose you need change 4, it will show the 4. And then you can change the distance also. Suppose you need 15 between the distance means 15 mm. So it will vary. See the difference. So once you can use the linear pattern, automatically create a multiple features like a holes, cut, anything. So this is a linear pattern. Linear is in the sense you can draw the multiple duplicate in the XY direction. It is a linear. Suppose you want to arrange a circular manner, circular feature, you can use a circular pattern. So go to circular pattern, I can draw the basic shape. So I can delete this shape or I can use a new file. I can choose part. This is a new project part. So now I can choose the same pen plane and go to the sketch mode. I can enable this grid view grid. Now draw the one more shape like a rectangular shape. See the circular pattern, I can draw the circular shape. So the shape will be like that. Or you can use the revolve command. So I can draw the line tool and create this model. So I want to move this sketch from the origin. So I can select this move entity, select all the model. I can select the sketches. Okay. I can select this one and select the move entity, select this point to some distance. It's a fully constrained. I can select this one. Scaling, okay, no problem. So I can choose the plane again and draw the profile from the not from the origin. I can give some distance. I can draw here. Now I can draw the center line using the origin point. Okay, so you can use the revolve feature. Your profile will be ready, and then the center line, center axis of rotation also ready. So go to the revolve feature. Automatically, it will be detect the profile and the revolving axis. It will be revolving for 360-degree. Just OK. Revolve feature. In this shape, I need multiple holes from this page. I need using the circular pattern. So I can select this one. Go to the sketch mode. I can set the view for using the control 8. Then now can draw the circle here using the quadrant point, exact quadrant point of the circle. I can choose a circle option. So here you can use this line. Okay, here I can draw the circle. I can set the dimension. I can use the dimension option. I give the dimension for 30 mm. Then I can fix the dimension from this point to this center point. I need exactly 115. Okay, fine. Now you can use the extrusion cut. Select this circle and I can throat cut. I can use. So it will be create a one hole like that. So now we want create a circular pattern for this extrusion cut. So go to the circular pattern. Select the select the direction, same like a linear pattern. So here the direction will be a circular manner. So you can select these edges or this face or anything or these faces, because circular means it will be same 360-degree. Okay, you can select any faces or edges. So this is our direction. Automatically show the preview. So this is for equal spacing method. So we can give enter the number of intensity for 8 and then total degree for 180-degree. So I can give the equal spacing. So automatically it will be equal spacing, equal angle degree will be distributed. Suppose you need to change the spacing, means you can use instant spacing. So now you can specify the 15-degree angle. The number of count will be 8. I can change the 3-degree, enter, it will show. So between the angle will be 15 degrees. Suppose you can change the angle for like for 90 degree. I can give a number of entities for 4. It will show the exact quadrant point of the circle. Okay. So I can click OK. So this is for circular patterns. Okay. So anytime you can change the dimension, means you can go to the sketch dimension. Suppose I need a like 10 mm radius. So automatically it will be adapted. Same like the pattern will be also adapted. Okay. Suppose I need same rib support from here. So choose the plane. See our front plane and the right plane is the correct one. I can choose any front or right plane and go to the new sketch. I can set the view. Now I can draw the line from this end point to this this side, the bottom side. Now finish the sketch mode. Now go to the rig feature, select the rig feature and give the exact direction and give the 10 mm. So okay, then give the okay, it will show the rig option. See the direction. Showing some error, I will check. So I can delete this line, draw the line from this portion to this portion. Okay. I will apply the result. See, so it will show the rig feature. Now I want a circular pattern for this the rig feature. I can select this circular pattern. Select the direction for this edges. I give the equal spacing. Same for I can enter 8 segments, 8 number of segments. Okay. Okay, this is a circular one. One more example for a sketch driven pattern is a special one. So it's nothing but you need any multiple duplicate. You want to use the point option. Suppose it's a simple one. Go to the previous model. So I can use this face. Go to the sketch mode. Here I can use some additional points using this point option. Before that, I can draw one exclusion cut option.
Participants, someone of your mic is switched on. Please switch off your mic because there is some disturbance. Participants, if you have unmuted your mic, please mute it. Participants, if you have unmuted your mic, please mute it. Balamurin sir, are you speaking, sir? We cannot hear you. Balamurin sir. Balamurin sir, are you speaking, sir? Your voice is not clear. Balamurin sir, your voice is not clear. Balamurin sir, your voice is not clear, sir. We can't hear you. கேக்குதா sir?
Voice is not audible, Professor.
Yes, sir. Please, sir. Let me check, sir. Let me check.
இப்போ என்னோட வாய்ஸ் கேக்குதா சார்?
Yes, sir.
My
Voice
voice is
கேக்குது,
audible,
but
sir?
slide share ஆகல, sir. Voice கேக்குது, slide share ஆகல.
Okay, okay, fine, fine, fine. I will change. Now we see my screen.
No, sir. Yes, sir. Yes, sir. Now it's
Fine.
clear, sir.
Okay, okay, okay,
Yeah, yeah. Thank you, sir.
okay. So now we can go to the sketch driven pattern. So I can draw extrude cut option. Now I can draw multiple points here. You want to edit the dimension, go to the dimension option. You can edit this the distance. So I can use sketch driven pattern. select these sketches selections. I can select these points. Now I can use the feature. Which feature you want to create multiples using these points? I can select the extrusion cut. So it will be based on the point. You will be creating multiples. So this is for a sketch-driven pattern. Okay, so mainly you can use a linear and circular pattern. So some advanced tool like sketch-driven, then table-driven. Table-driven is nothing but you can create XY coordination point in Excel sheet. Then you can import to the sheet and then automatically create a part. You can use the sheet metal. You can create a multiple holes or anything. You can use this table-driven pattern. Then variable pattern, you can use different pattern shapes like plastic parts. You can create any grill shape or any ventilation shape. You can use the variable patterns. So commonly you can use the linear pattern, circular pattern, then sketch-driven pattern. Sketch-driven pattern, you need points, preference points. Okay, so you can use the points. So automatically create a feature, anything. Okay, fine. Next one is wrap command. This is the last one. Then go to the model. Okay, I can create one model and go to the Cura software in how to simulate the 3D printer option. Okay, so wrap command is nothing but sketch contours on the face. Like this is our part. I can create any part name or like any extra like emboss, any symbols, company symbols or part name. You can create here. You can use the wrap command. So I can select this face. I can go to the sketch mode. I can use Control 8 for this orientation view. Now I can use the text option. I can draw. I can give the text value like 3D printing. So it will show the text here. From you can create an origin point. So just okay. Then I can move the sketch for this face. I need this face. So I can select the sketch like that. Now I can click exit the 2D sketch mode. The sketch will be like that. Okay, the 3D printing. Now I can use the wrap command. Select the method, wrap method, emboss or engrave or deboss, like a deboss. It's a sketch 4. Then select the face, this face. So I can use the emboss mode, the direction of this, I mean thickness of this value is 1 mm. Suppose I can give 3 mm here. This is a 3 mm. 3 mm means it will be a extrusion of 3 mm from the face. Like I can enter, it will show like that. See, I can zoom it. It's a 3 mm. This is the distance is 3 mm. Suppose you want to change the means, you can edit this feature. I can enter for only 1 mm. So this is our emboss option. Okay. Suppose you need a engrave, like emboss, deboss option. Like the same, I can change the direction. So go to the edit mode. I can select this deboss option. Click OK. Same 1 mm. This one 1 mm depth. So see the difference. It will be grooving. Okay, like that. You will cut the part, previous part. Okay. So the deboss. This is for wrapping command. So one more example for wrapping is a best use for circular feature. Circular shape, any shape, you can easily draw the shape. I can choose circular shape. I can choose a new file, choose the front plane, and create a sketch mode. Draw a circular shape. I can use like shape. I can use the visible the gritter. I can choose the line. I can draw this line. You can fix the dimension. I can give 100 and then fix this one. So 15 and then this one 20. This is for 75. And I give the fillet value. So I can give 5 or 10. This is our shape. I can give the center line. Now I can go to the revolve feature. So the part will be like that. It's a circular manner. See, I need a wrap command for this face circular feature. I can draw some design. So before that, I can need select this work plane. So this is a circular one. So we have only for front and top and right plane only. So you can choose front or right plane. You can use the same plane option. You can create the offset from the right plane. So you can use a plane option. Select this plane. So offset value will be 80, which is the previous value. I can decrease the value for 30 mm. Okay, my offset plane from the near to the part. So 30 is okay, or you can decrease 25 also. Okay, this is our new plane. In this new plane, you can draw the wrap profile and go to the sketch mode. So now I can draw the some model. I can draw the spline option. Randomly, I can draw this shape like that. Go to the plane option. Okay, so this is a we need a closed profile. This is an open profile. So I can choose offset from offset entity. I can select this one. So this profile will be offsetted for 10 mm. So 10 will be very high. I can decrease the dimension for 2 mm. Okay, I can draw the dimension like that. Now I can go to the offset. So see that 2 mm distance. So this is open profile. I need to close this profile. I can use the line tool. On another side, I can draw this line like that. This is a closed one. Okay, this is our wrap profile. Now apply the wrap feature. Exit the 2D sketch. Go to the wrap command. Select this profile. Then select the face. This is our cylindrical face. I can select this one. I can select the operation bar deboss. So with 1 mm radius, so 1 mm depth, I can give enter. See the model. Suppose you want to emboss means you can change the operation. So edit the feature and change the operation. You can enter the corresponding thickness. So it will be adding the material. Okay. So suppose you want to multiple means the same. You can use a circular pattern also. So circular pattern. Select the direction and number of count will be 4. Then select the feature for this emboss. Go to selection the wrap command. Then give the So select this one. I'm gonna select this. See what this like. So it will look like it is overlapping. You can decrease the count, so it will show the value. Okay. So this is our wrap command. Okay. So same you can work with the sweep, but you can same sweep operation. You can choose the two profile like profile and path. You can automatically cut the sweep option. Same left. So this is for a solid feature. This is for like on the cutted vision. This is for void. This is for void operation. This is for solid operation. Solid means it will be adding the material. Same corresponding extrude cut, revolve cut, and sweep cut is removing the material. Is a void features. Okay. So now I can draw the shape model, one model. Then go to the import to the Cura software. So I can draw the model. I can delete this the previous one. So now I can choose a new part. So I can choose front line and go to the sketch mode. I can visible the grid option. My unit is a mm. You want to change the millimeter or centimeter, you can change it here. Now I need only mm value. I can select mm as a unit. Now draw a shape like a line tool or line tool. Go to the line. I start from the origin point. I can draw the line of some dimension like that. Okay, my shape will be like that. Now I can edit the dimension. Go to the smart dimension option. I can give the value for this is for 66 mm. Then edit this side also 60. Then okay, fine. This is 60 and this is 65. Then between the distance, I need a 12 mm. Here also 12 mm. Okay, so I can fix all the dimension. Now finish the dimension mode and I exit the sketch mode. Now I can use the extrusion option. My extrude value is around 42. So I need a between the plane. So I can use the mid plane option. So total is 42. From the here, this will be 21. Here also 21. So this is for extrusion operation. Next, I need chamfer value for these edges and these edges. So I can use chamfer option. Go to the chamfer. Or chamfer option here. Go to the chamfer. I select these edges. So I can select only edges, not face. You want to select the face, mean you can select right click the feature and clear the selection or delete the selection. Then I can choose edges only. This chamfer value I can use the distance method. Distance to distance method. I can enter the symmetric value for 12 mm. Yeah. Same I can use the opposite side also. Select here. So this is also 12 mm. Just to OK. The part will be like that. Okay. Then in top face, I can use the fillet option. So I can use the fillet value for 12 mm. So to say 21, so I can use this one and also select this one. So my value is symmetric value for 21. So it will be like that. Okay, this is a simple model. So now I can draw the supporting feature like that here. The thickness of, you can use the rib option. The rib thickness will be 12 mm. Then this height will be around 42. So I need 42 from this line and draw this one. So I can say select this face, or I can select the plane first. I can choose the front plane, go to the sketch mode, new sketch. I need a line for from here to here. It's a 42. So I can draw the line. Now go to the dimension option. I need a 42 mm. Okay. Now I can draw the line from this point to this end point to this point. Okay. So I need only this line for reference only. So I can select this line, and you can use the for construction purpose. I can select this one. So this is a dotted line. It's converted to dotted lines. Okay. I can exit the command. Now I can use the rib option. So automatically give the 10 mm value. Then direction will be the quarter. So I can click OK. So it will be created like that. So this is our simple part. Okay. Suppose you need two holes here. So select this face. Go to the sketch mode. Draw the circular shape. You can fix the dimension. So I can enter the radius of diameter at 5 mm. Then distance from this edge to this edge, I need 8 mm. Then this point to this point, you need 20. Click OK. I can use extrusion cut. It will be created extrusion cut. So I need one more hole from opposite side. So again, you can choose the faces and create a circular and use the extrude cut. But I can use mirror option. So this is our mirror feature. So you want to mirror feature, you can need a mirror plane. Okay, you need a mirror plane. So before that, I can use a mirror plane like a front plane. Front plane is the middle plane. So in this part, front plane is the middle plane. So I can use the mirror option. Select the plane first. So I can go to here, say property window, go to here. I can choose the front plane. Then go to the feature to mirror. Which feature we want to mirror? I can select the extrusion cut. So automatically show the preview. Just OK. You will be creating a duplicate. Okay, this is a mirror option. Okay, fine. So now I want to save this file for in step file format. So go to the save option. You have a save or save as. You can select the save as file. So here you can choose the file format. So I can choose a lot of file format will be there, like IGS file, then CATIA file, then e-drawings. Now we can choose STL format. This is the format to import the model in Cura software. So I can choose STL file, step files. So I can select this one and select. I can select in desktop. Create one folder here. I can save the file. So see, the triangulars is 440. The step file is converted as a layer by layer. So we can show the file sizes and triangulations. 440 triangulations will be here. See, this is our preview. Just OK, I need yes. All the bodies I can select. So we can create one model in SolidWorks and then save the file as a STL file. Now I can open the Cura software. So this is a free source software. It's a Ultimaker Cura. So here you can use preparation and preview, then monitor. So here our 3D print sizes. Based on the machine, you can need bed sizes. Okay, you can change the machines automatically. You will share the preview. Okay, scheduling loading. Before that, I will give one video, display one video. It will show how to work the 3D printer machine, and then how to the operation, and then how to work the Ultimaker Cura also. I can play the video. Before that, it will be loading. I can play the videos.
This is a 3D printer. It takes dimensional models, save them in the computer, and physically creates them right before your eyes. 3D printers are both fascinating and each year the technology gets better. In this video, I'd like to walk you through one of these machines to show how it works. My name is Jared. I create 3D animations to show and explain. Hit the subscribe button to be notified about future videos just like this. This video is sponsored by Bamboo Lab. In science fiction, they sometimes have this device called a replicator. You can ask it to make almost any object, and it somehow materializes right in front of you. Today, we don't have replicators. The 3D printer is starting to do some of the same things. It doesn't happen instantaneously. It's still quite impressive at what it can do. 3D printing is a type of additive manufacturing. You start with nothing and then add materials layer by layer until it's complete. Compare that to subtractive manufacturing. Start with block materials such as metal, and you remove parts from it to form the final product. Notice all the excess waste. Additive manufacturing, there's much less waste of materials. This is an advantage to 3D. Yes, it's true. 3D printer can be used to create all sorts of toys, minifigures, movie props, you name it. But keep in mind that a 3D printer can be used to create objects that have a more practical use. A lid holder for your kitchen, zip ties, adjustable supports for just about anything, a Wi-Fi QR code sign, and even a customized broom. Very useful for your kitchen. You can even 3D print accessories for your 3D printer. Only limited here by your imagination. In the real world, there are some other interesting uses. 3D printed food, yes, it really is edible. 3D printed clothes, and 3D printed prosthetics for those that need replacement body parts. Large-scale companies are using 3D printing to manufacture products because it's less expensive and quicker to produce. Companies like SpaceX are literally 3D printing parts of their rockets. NASA is hoping to use 3D printing to create items when astronauts are far from home. This means they don't have to bring as many tools and spare parts into space. And there are even 3D printed houses. Instead of plastic, they are made with a special concrete-like material. Yes, we actually live in them. It looks quite nice, if you ask me. There are different types of 3D printing. The most common one, and the one used in this video, is called fused deposition modeling, or FDM. It takes a long strand of filament. This is usually some form of plastic, but it depends on what you're printing. Then it melts it into a specific pattern to form a layer. These layers go one on top of the other until we finally created the 3D object. The filament usually has a thickness of 1.75 millimeters, about the thickness of 2 credit cards. Filament for the printer we'll be looking at today comes in these large spools. You can get them in almost any color that you want. The filament comes in several different types. Don't worry, you don't need to memorize any acronyms. Just know that PLA, or polylactic acid, is the most common and easiest to start with. Some of these materials are more rigid, meaning they don't bend. Others are more flexible, and some of the advanced materials have more strength, can withstand extreme conditions. For this video, we're going to walk through the A1 3D printer by a company called Bamboo Lab. This company is really on the cutting edge of technology and has a lot to offer. As of October 2024, the A1 costs $339 US. Bamboo Lab has been working to get these 3D printers into the hands of consumers like you and me. The printer is about as big as a desktop computer, very easy to put on a desk right next to your workspace. Let's take a closer look at the A1. This part is called the gantry. Your 3D object will be printed on metallic build plate. This can be removed so that it can be washed or even replaced. It's held on by strong magnets directly at the beam. There is a touch screen right here to control the 3D printer. You can also control it from another device, such as a desktop computer or even your mobile phone. At the top of the machine, there is a plastic support arm that folds the filament. The end of the filament is hand-fed into the tube opening shown here. Then through the plastic tube, which connects all the way down to the tool. Inside, the filament will be melted and come out the very bottom. Inside the tool head, there is a stepper motor, which will spin to pull the filament through to where it is mounted. Now, in a regular electric motor, it uses electricity and magnetism to continuously spin in one direction. A stepper motor is different because it can be precisely positioned and will stay there until instructed to move. There is another stepper motor over here. When this spins, the belt goes all the way across it. Moving the belt causes the tool head to move left and right. This bar is called the X-axis linear rail. There are two threaded rods on each side. You can actually see them if you move in far enough. When they spin, the rail and the tool up and down. I call these C-axis linear rails. This means the tool head can only move 2 dimensions, but this is a 3-dimensional printer. For the 3rd dimension, the build plate moves back and forth on the y-axis. Down below, there is another stepper motor that spins with the belt. This is what moves the build plate back. 3 dimensions of movement allows the printer to create your 3D models layer by layer. There is a camera up here to take images of the objects as they are moved. You can even make a time-lapse video, which is really fun to watch afterwards. 3D printing can be as short as just a few minutes, or as long as several hours, or even a day or two if your object is complex enough. The area inside of this imaginary box, this is called the build volume. You can only create 3D objects that fit inside the build volume. If you want to print something bigger or maybe more complex with more integrated parts, you can still do that. You just have to find a way to print it in several different pieces. 3D printers from Bamboo Lab come with a handful of 3D models ready to print and built into the 3D printer for easy access. This little boat is commonly referred to as a benchy, which is short for benchmark. It's a common first item that you print to test the speed and quality of your printer. To get more 3D objects, you can download them from MakerWorld or one of several other websites. Any of these are completely free. You can also create your own models with software, but this takes a little bit of learning. You can even use 3D scanning, take objects in the real world and create your 3D model. But either way, once you have your 3D model, it needs to be converted into a format like a 3D printer. Your 3D object will probably be in one of these formats. You take that, run it through a program called Slicer. This takes your 3D model and splits it into many distinct layers that can be through. Slicer uses this to produce something called G-code. This is the step-by-step instructions for how the 3D printer should create your 3D object. These are very specific instructions on how to move the stepper motors. This controls where the tool head and build plate moves, as well as when the filament comes out. Fortunately for us, you don't need to understand this G-code. You just need to send it over to the printer and it does this. So let's walk through an example and see this in action. Once you press the print button, the build plate starts moving up, as well as the hot end. Inside of the tool head, the stepper motor starts to spin, which pulls the filament through. The part at the bottom, this is called the nozzle. It's the piece that gets really hot. If you're using PLA, one of the most common types of filament, will heat up to 220 degrees Celsius. Even with the protective cover, you definitely don't want the filaments to near this during the printing process. At this point, the tool head will come over to the left side and begin to purge some of the filament to make sure that it's flowing. This is called purge filament, or informally known as printer. Yes, the printer has got to put it somewhere. Many people will actually 3D print a special container to catch all of this purged filament. Now that the filament is flowing, the 3D printer will take additional steps to prepare for printing. One of them is called bed level. This is making sure that the build plate is completely level. Any offset between flaws in the bed leveling usually takes at least a few minutes. Modern 3D printers make bed leveling automatic, much easier than previous generations of 3D printers. Right before it actually starts printing, it usually draws a few lines at the front to make sure it's still flowing. At the back of the build plate is the nozzle wiper. Sure, hot end. After all of them, finally ready to start. First layer is extra important because it has to stick really well. This is why the build plate is heated. The build plate is usually textured to help it stick a little better. Sometimes a special glue is used. Oftentimes, the printer will draw the outline of the layer first and then the inside. This inside part is called the infill. You could make this part completely solid, but that would be a waste of film. It's common to do about 15% infill, just enough to give a structure on the inside so that things maintains its shape. When it's done printing, keep in mind that the build plate will be hot, so use caution. You should be able to grab your new item within a few minutes. It cools pretty quick. There's the A1 3D printer in action. Let's take a look at this 3D model. When printing the overhanging portion of this model, it would be necessary to print into thin air, which is not possible. For something like this to print correctly, it needs to have supports in it. It's the green tree-like structure that you see here. Another example, let's try to print the gateway arch. In my last video, we saw that during the construction, it would have collapsed without using extra supports. The 3D printer is doing this at a much smaller scale. The same idea still applies. Bamboo Lab software allows us to add supports that will be printed along with the original model. You'll notice that the 3D printer does okay with some. Once it gets to the top, we need those supports. When it's done printing, the supports can be broken off. That 3D printed gateway arch. There was a time when you could only print 3D objects in one color. The A1 3D printer has the ability to print in several different colors. For this to work, you need a separate device, AMS light. That stands for Automatic Material System. This connects directly to the A1 printer. You have room for 4 different filaments. Then there are 4 clear plastic tubes that connect the AMS light to the A1 printer. This is called filament.
Hello.
The end of each filament spool is fed into the holes inside.
For 5 minutes, sir.
And a motor starts pulling it through the tube. Filament spools from Bamboo Lab have an RFID chip.
So so you know the operations. You understand the operations using the videos. So now I can import this model. So I can select this file here. I can open the Ultimaker Cura. I can say already I can design the model. I can choose the model like part 4. Part 4. I can open it. So it will be loading. So this is our part. So it will be rotating. So see our model. I want to orientation this model. I can use preparation window. Here I can move a part, select this part. So here our orientation, we want to move or rotate the part. Suppose this is our preparation window. The machine will be understanding how to create this part. Okay, you want to rotate the part, you can manually rotate here. Suppose you can rotate here means you can select this one. You can rotate this direction, and you can select this Z directions. So I can load the file. Now I can use the slice operation. So it will be slicing the layer by layer using the corresponding parts. So this part will completed, total model will completed for taking 1 hour 30 minutes to complete this model with the dimension. The whole part will be 30 grams, and then total height will be 3.75 meter. So I can give the preview. See the simulation view. See, the part will be created like that. I can rotate the model. See, this is our abbreviations. Okay, this is our final output model. You can save this file, directly feed to the machine. So automatically it will be converted to the part using the 3D printer. So and the time is 6:30. So, yeah. Okay. Any doubts? I wind up the
Thank you very
session.
much, sir.
Thank you, sir. Thank you.
Thank you very much, sir. Participants, if you have any doubt, you can ask. Moreover, please enable your videos so that we can take a screenshot of this. Participants, please enable your camera so that we can take a screenshot of this. Just a minute. Thank you. Thank you very much, sir. Your session was very nice and it was very informative. Hope all the participants have used this session in a good manner, sir. Thank you very much, sir. Thank you. Participants, it's time for test now. It's time for test now. The link is shared. You can log in through your attend login and then participant login, and you can complete the test. Before that, a small validity function. Just a minute. So, good evening to one and all. It gives us immense pleasure and deep sensation of satisfaction to stand before you today as we mark the successful culmination of our 6th ATAL FDP program on futuristic manufacturing with 3D printing with digital fabrication, hosted by the Mechanical Department of Adhi College of Engineering and Technology. This FDP has been an enriching experience filled with knowledge, sharing innovative ideas and collaborative learning. The theme of the program was carefully chosen to address current academic and technological needs. And I am proud to say that over the past 6 days, we have collectively explored, discussed, and reflected on several pertinent topics that will be undoubtedly enhance our professional practice as educators and researchers. We are privileged to have us with a panel of eminent experts and research persons from reputed institutions across India, each bringing their unique perspective, expertise, and experience. Their engaging sessions have not only broadened our horizons, but also inspired us to think critically and teach innovatively. I would like to express my heartfelt gratitude to the AICTE Training and Learning ATAL Academy for entrusting us with the opportunity to organize this FDP. Their constant support and guidance have been instrumental and in the successful execution of this program. A special thanks goes to all our distinguished speakers and resource persons who graciously accepted our invitation and shared their insights with us. Your contribution have added immense value on this program. To our enthusiastic participants from various parts of the country, your active involvement, thought-provoking questions, and eagerness to learn have been truly commendable. We hope you are leaving this FTP with new tools, new knowledge, and a renewed passion for teaching and learning. I would also like to appreciate the relentless effort of the organizing committee, faculty members, technical team, and support staff who worked tirelessly behind the scenes to make this program a resounding success. As we draw this FTP to a close, let us carry forward the spirit of knowledge learning, and collaboration. May the knowledge gained here translate into impactful teaching, meaningful research, and positive change in our academic environments. Thank you all once again for making this FTP a memorable and impactful journey. Wish you the very best in your academic and professional endeavors. Thank you, one and all present here. Thank you very much. You can complete your session and you complete your test as well as the feedback form. The feedback form is posted in the chat box as well as the link is in your participant login of ATAL. Thank you very much. Thank you all. You can all sign out. Thank you very much.
Thank you, sir. Thank you so much.
Thank you,
very
Professor.
much. Thank you, sir.
Thank you all. Thank you very much.
Shall I leave, sir? Shall I leave?
Yes, sir. Thank you all, sir. Thank you very much. Thank you.
Thank you, sir.
You all can leave, sir. Thanks for being the part of our session. Thank you.